Splunk or an Elasticsearch type of deal. All your HTTP, DNS, SMB. If anybody's used Bro before, you know Bro generates a massive amount of logs. Suricata does kind of the same thing. It's not tab separated. It's JSON, but you get a lot of information there. File extraction is awesome. So any files you see going across the network like an HTTP, you can write a rule, trigger for that rule to download to disk, and you can do initial post-processing. So if you had a rule that would say, I'm looking for an executable of this certain size coming from this location, everything I want to write from there, download it to disk and throw it in Cuckoo to like auto sandbox it, right? So you can do that kind of stuff. We have IP reputation. So if you can have a flat file of all these IP addresses, like if you're in an active incident, and you know where your attackers are coming from, or you think you know where they're coming from, you can then apply those IPs to existing rules. So if I have a rule that just says, show me when there's an HTTP post, you don't want that to fire all over your network, because that would be crazy. You can apply IP reputation to it and say it has to come from this address, anything in this flat file. So that helps out a lot in an incident. If you want to do cool stuff like brute force XOR, all the executables that come across your network, you can use something like Lua to do that. Lua is a whole programming language. You can export fields out of Suricata into a Lua script, and you can do really whatever you want with it. Very similar to Bro scripting. It's cool that we're backed by a nonprofit because we can't be sold or bought out or anything. Suricata generates NetFlow, has really good support for SNTP, native IP6, and we've got a lot of cool stuff coming up in 4.1. So today, Suricata stands at 404, response code joke, but and somehow we skipped over 403. But so if you look at the thing, you're like, what happened to 403? We just didn't do it at all. But our detection capabilities were super extended. We got way more buffers, which Jack and I were super happy about. Things like Jack will kind of cover when he talks about writing SIGs. We got a lot of TLS improvements, more buffers there, which we'll talk about as well. The Rust stuff is really awesome, helping us build more secure protocol parsers. Eve expanded, so we can have even more data in there. TCP stream was rewritten for like the 8th time. We can use something called bypass. So if you're looking at SSL traffic, you know, after the certificate appears on the network, everything after that, Suricata can't read it, doesn't care. But it will still try to process it, unless you have bypass enabled. Bypass will be like, all right, I saw the cert, I don't care about anything else. So this makes it, you know, what is it, like 40 some odd % of traffic now is SSL, so that's a lot of traffic. If you can cut that out, you don't have to look at it, like, boom, I just made my sensor way more performant. Lots of bug fix. And there was a pretty cool CVE that was contributed by Positive Technologies, I think. Detection bypass, that was pretty cool. So Suricata needs to see a 3-way handshake occur in order for it to start watching the traffic and know what it's looking at. And if you don't follow the rules that Suricata goes by, you can bypass and send your traffic without doing that handshake. And that was pretty cool. But that's fixed in 4.04 and 4.1. We also recently released a tool called Suricata Update. So it used to be you'd have to use something like pulled pork, oinkmaster, something like that to update your rules, manage your rules. So the emerging threats rules that is like 35,000 rules these days. So it's a lot to kind of take in. Based on what you need on your network, you may want to enable or disable rules. Suricata Update will allow you to do that and make it so that when you grab the rules tomorrow, all your changes will stay there. It's pretty well documented. There's a read the docs. I know you guys can't click on this, but we're going to tweet out a link to the slides afterwards so you guys can have this as a reference. You can add in lots of really unique rule sources if you find a new rule source that you want to automatically keep pulling down. There's kind of a framework for that. And yeah, really cool. If you know Python, that's a great place you can contribute to if you're looking to contribute to an open source project. So I changed this title last night, and it was accurate because Suricata 4.1 beta is up right now with a lot of really cool changes. One of these changes is a keyword in the rules called starts with and ends with. It used to be that if you were going to say that I know my HTTP URI ends in .php, you'd have to use something called isDataAt. And it's like the word isDataAt all squished together, and then you had to use an exclamation point to say not, and then 1 to say it's not 1 byte after my previous content. Let's just make it simple and say it starts with this content or it ends with this content. So really cool. Makes your rules way more readable. We have a keyword in here called B size or buffer size. In rules, we can write, when we're writing TCP or UDP rules, we can use a D size modifier to specify how big the data should be. But now we have B for the buffer, so pretty awesome. One of the cool things that Suricata is going to do now is transforms. So if you're dealing with JavaScript or HTML, white space is the enemy, because you can throw it all over the place, doesn't really matter. The browser will still parse it, but if I'm trying to write rules on that traffic, it super sucks, because I have to account for that. And the way that I account for all this white space when I don't know where it's going to be is I write these garbage PCRE expressions that uses up all the CPU in my sensor. So what we'll be able to do is say, take a JavaScript file and compress the white space, or strip the white space. Compressing it will just reduce everything to one space, stripping it will just pull it all out. And then you write your rule based on that content. Super, super powerful. Like, we see phishers, exploit kits, they all add lots of white space to stuff. So this will be a way for us to normalize that so that we can kind of get by it and make sure our signatures will work. Another transform is SHA-256. So if you had a content that you kind of wanted to keep secret, or you didn't want to give it away too easily, you can use a transform in your rule, and instead of writing www.notgoogle.com, you could SHA-256 that, put it in your rule, and then someone would have to brute force it to figure out what the actual content of it was. We have to thank Fox IT for funding development of the SMB protocol in Suricata. We had SMB1 and DCRPC basic protocol stuff in there. But now we have it re-implemented in Rust and added in SMB2, SMB3. The logs are really awesome. We have full Eve JSON logging, full file extraction, and so you can write rules on a lot of really cool buffers that are present in SMB. I'm really excited to start writing rules about that. So installing Suricata, there's some pretty good docs, and I won't just read the docs to you here because they're on the internet. You can build it from source if you'd like. There's tons and tons and tons of support for all different OSs. The easiest to get going is just grab the OSF PPA if you're using Ubuntu, pull that down, and then just sudo apt-get install Suricata. Lots and lots of walkthroughs for all sorts of different weird systems that we've kind of cataloged over the years or on our Redmine. And you can even install Suricata on Windows. It works pretty well, but run it on Linux. So we have a lot of options when it comes to network cards. We generally recommend the Intel NICs because you just have a bit more support for those. If you're using something like PF-Ring, the kernels are natively developed for Intel, so the Broadcom you're going to have a bad time. If you're doing like over a gig per second, you're probably going to need like a 10 gig Intel card, or you can go to specialized hardware. We recommend it. Napatech, Endace, and Miracom. These guys all have good support for using Suricata with it. You have to compile support for that card in when you build Suricata. We really recommend, if you're using a recent Linux kernel, use AFPacket version 3. PF-Ring is really cool, and when that was the best option around, I used it a ton, but after recompiling the kernel and the tools, every time my kernel updated, it really became a drag. So AFPacket version 3 gives you a very, very similar performance as to PF-Ring, but it comes without the cost of managing it. And then if you're doing a sniffing interface, turn off all the optimization settings on your network card. I think Doug Burks has a page, the creator of Security Onion has a page that I've gone to approximately 5,000 times, and it has just a big long command for like turning off all of the options on your network card. Because we don't need the network card to do stuff for us. We just want to see the raw packets. We don't care about checksums. We don't care about a whole bunch of other stuff. Just turn it all off. So under a gig, basically anything will work. Like you can use a Raspberry Pi to handle a few hundred megabit per second of traffic through it. Unless you have like tons and tons of really terrible rules, like lots of PCRE rules that don't have good contents, aren't anchored anywhere. If you dumped out like 500,000 DNS rules from your MISP instance or your CRITS instance, it's a bad way to go. Don't recommend that. If you're somewhere where you're decommissioning old hardware, like keep your eyes out. Just grab some of that hardware. It'll run Suricata just fine for a couple gigs usually. My thing was I would always keep an eye out for what servers were coming off of support when I worked in the enterprise, because they'd be like, well, we don't have anything to do with these old DB servers. Like, what are they? They're like, 64 core, 300 meg or 300 gigs of RAM. They're like, we're not going to use them. Like, are you crazy? These are amazing servers. I'm totally taking these. Under 10 gigs, you're going to be tuning. You're going to need at least 16 cores. Maybe you might need to get into some accelerated capturing. Storage kind of starts to become an issue here because you're going to be generating a lot of logs depending on how you're looking at your traffic. And bypass is going to make a big difference for you. Above that, it's entirely possible. We know some 100 gig plus implementations. This is something we get into in our advanced user training, how to tune these up, how to spec out your hardware properly. But this is the serious world where you're going to be spending a lot of money and doing a lot of optimization. There are 2 papers here by one of our core team members, Peter and Mikhail from Firefox. Yeah, Mozilla. And these are basically optimization guides of like real-world tuning recommendations. If you have a sensor and you want to tune it up, these are the 2 articles you have to read. It's called SepTune. So the run mode, Suricata is a network security monitoring tool. So you can run it without any rules, and it'll print out lots and lots of information about the HTTP traffic it's going to cross, DNS traffic, TLS, all sorts of stuff. SMB now. You can run it IDS mode, so you don't get that all that metadata. All you're going to do is fire off on rules, like the typical IDS. Intrusion prevention has to be inline. NSM plus IDS is the most common implementation we see, where you're firing off on your rules, you're generating metadata about the traffic you're seeing, and really creating a full picture. If you've worked with an IDS before, you've probably run into this where you see this alert fire and you're like, oh, Trojan, sounds super bad, but you have no context around it. You don't know what happened before it, you don't know what happened after it. The signature might have only hit on one very small part of it, but when you have the full view, so you can see all the HTTP traffic that occurred before, you can see they went to a terrible porn site, you can see they downloaded this APK, and then their phone got infected, you can see all sorts of stuff. So seeing the whole picture is really the best way to go. There's one big configuration file for everything in Suricata. It's just the Suricata YAML file. Everything is configured here, and it's pretty well documented. It's pretty well shown what you need to do there. Everything is here on the read the docs. You guys might be able to see that. But it starts off with, like, if you look at the configuration file, it's like step 1, tell Suricata what it's looking at. So like you have to define the network that you want to protect. It's called your home net. Usually this is just the 192.168, the 10 dot, the 172.16 dot, whatnot. And you can configure this for however you want. So whatever I'm protecting, I call that my home net. And whatever I'm watching out for, whatever's outside of my home network is going to be my external network. Pretty straightforward. If you want to configure your AIM servers, we still have a configuration option to do that. RIP AIM. You can set up all sorts of variables in there, and you can use those in your rules. The next thing, you scroll down, you're like, which rule sets do you want to enable or disable? We have lots and lots of rule sets. You can write your own rules. You can download the emerging threats open rules. Jack's going to get into rules in just a second, but you just uncomment these to enable them. And then the last part is you just select how you're going to output this. Are you going to put it out to a syslog? Are you going to write it out to the JSON file? Do you want to append it, or do you want to write a new one every day? How do you want to do your rollover? All of these kind of things are configured in the YAML. There's lots and lots of comments. So typically, Suricata is still deployed on the perimeter. We see some companies moving towards the inside because everybody's afraid of lateral movement and whatnot, and rightly so. So we see it on the host occasionally, but really the big thing here is if you're managing lots of sensors, make sure you're setting your home net and external net properly. Because if you don't tell Suricata what to look out for, it's not going to know how to defend your network for you. The rules can be expensive. Like I said, emerging threats has like 35,000 rules, so really only use what you need. Enable and disable these rule sets as they pertain to you. If you're not running a web server in this area, don't use the web server rules. If you're not looking out for Trojans or DMZ-based things, don't use those rule sets. And now Jack will take over.
Awesome. So one of the things that Suricata will generate are logs. So one example is what's called the fast.log. It's a fast log. It spits out exactly what you need to know when your rule fired, but nothing really more than that. So you see sort of the source IP, where it was talking to. You see the message. So like what rule actually fired. What am I looking at? So in this case, we have like an IP lookup, a dynamic DNS domain, and then a bunch of Trojan for a Trojan called formbook, right? So as an analyst, I can look at this and say, yeah, this is bad. Like, this is bad news. Rip that computer off the wall, throw it away, burn it in the fire, you know, whatever. But unfortunately, it doesn't give you anything more than this. So we have, you know, very basic information. But that's where eve.json comes in. So this is your log that contains everything. This is also a log that gets really, really big, like gigs and gigs and gigs in no time, because it's literally grabbing everything you would ever need. It's basically the next best thing to full PCAP. It's easy to parse. It's really easy to throw into your Elk Splunk instance to sort of aggregate there and search through it. It prints all the information that's included in fastlog as well, but just everything else around it. So it makes Suricata more of that NSM than just IDS IPS. So here's kind of an example of what a DNS query looks like in the eve.json file. So it's pretty cool because I can look at this and say, so I'm looking at a DNS query, I see a text record. Oh, what is that, PowerShell in the text record? That's probably not good, right? But it's a really easy way to see that and be like, I should probably be looking into this and figuring it out. So let's say I did see this, I wrote a rule for it. This is kind of then what that would look like when that rule fires. So again, we have our timestamp, we have a flow ID, we sort of just have all the information, including, you know, who generated this query, where was it talking to. We see the signature fired, we see the rule message, all that information, and then we also see the payload there. So as an analyst, this is really useful. I know it's kind of hard to see, but essentially, it's everything you would need to know to understand what happened in that instance. This is an example of HTTP, like an HTTP request. Again, I'm sorry, it's hard to see, but basically we're just seeing everything about that transaction, the protocol, the destination port, in that request. What are the headers? What was the actual response that came back? And then all of the other like metadata around, you know, the flow, how many PCAPs were, or how many packets were in that flow. And then if that rule did fire, this is then what we'd be able to see. Again, it's hard to see, but the point is that's a lot of stuff to look at, and as an analyst, that's great, because when you're trying to investigate an incident, when you're trying to investigate true positive versus false positive activity, we want to know as much as we can about that situation, and this is where you can see that. But again, because of how robust it is, it gets huge. This file can get really, really big, and it can cause problems if you're not ready for that. So I know we talked a lot about rules. Whoops. I know we talked a lot about rules, but let's actually talk about what is an IDS rule for those that aren't really familiar. So consider this traffic, right? We have an HTTP post. This is just a screenshot from Wireshark. This is an HTTP post, and we see some pretty suspicious stuff here. Does anyone want to call out? Just, you know. Yeah, the user agent's super weird. You know, detox crypto. We have a URI string of generate.php. We have a public key in the HTTP client body. Any guesses as to what this might be? What kind of malware? Ransomware. Yeah, exactly. Yeah. Yeah. So this is definitely ransomware. So this is evil, and we want to write a rule for it. So we can do that. So this is what a rule would look like if we wanted to capture this traffic. Now I know this looks like a huge pile of garbage. So let's actually break this down and understand what we're looking at. So this is the basic IDS rule format. So we start with an action. So we're telling the engine sort of, what do we do when this rule matches? So when our pattern matches, what do you want me to do? 99% of the time, we just say alert, because where we sit, we can't really dictate what you want to do with your network. But if you're in your network and you say, yeah, I never want these rules to pass or to be allowed, you can use something like drop. So you can tell the engine, hey, if this rule matches, just drop it. There's also reject, and then there's also pass. So if it's something that we don't care about, let it go through. But again, this is just telling the engine, hey, what do I do when I see this evil traffic? Protocol. So this is what we're telling the engine what to look for. The really basic sort of four are TCP, UDP, ICMP, and IP. But then with Suricata, we have specific protocols. So we have HTTP, DNS, TLS, SMTP, FTP, a bunch more. SMB, yep, that just dropped today. What this means, though, what this makes it really powerful is that if we tell Suricata, hey, look for HTTP traffic, it's going to look for HTTP traffic on any port. So if you have something that's doing HTTP traffic on some goofy high port, Suricata can still parse that as normal HTTP. The other IDS that's out there can't really do that. You have to tell it what ports to look for HTTP traffic on. So if, again, this Trojan is doing some weird stuff on an off port, but it is still the HTTP sort of protocol, we can see that, and we can still write our rules for that. So it's really powerful, and we're able to really be efficient in the way that we can detect this stuff. So after giving it an action, giving it a protocol, we want to talk about who's talking to who and how. So essentially, this is where we indicate who started the conversation and who they're talking to. So this can be something like a single IP address. This can be an IP range, or it could be a variable. So that was something we kind of saw in the screenshot of the YAML configuration. We have like sort of our home net variable, which is your typical like RFC 1918 internal networks, and then external net, which is basically not what's in your home net. So if we wanted to say, person in accounting's computer talking to evil website in Russia, we would say it's our home net talking to the external net, right? And then sort of following that then would be the ports. So we would basically be able to say what port is this traffic occurring on. Again, if we're using a protocol specific, so if we're saying HTTP, we would just put any for both ports. We would put any on sort of the home net port because it's a randomly assigned port, but then we can put any for the external port because it could be 80, it could be 8080, it could be 8443, it could be 30,000, I don't know. So we can just put any there, which is really powerful. So following that, so as we saw in our logs, what do we want it to say when this alert fires? As an analyst, what do we want to know? You can put anything here. It's just a free-form text field. But it's useful to be as detailed as possible. Again, if you're an analyst and your rule fires, you want to know what happened. You don't want it to just say something really generic like Trojan. Like, okay, what? Like, what kind of Trojan? What exactly was it? Do we have a name for this Trojan? Do we have an architecture for it? Is it .NET? Is it Win64? Is it Linux? Is it Mac? Whatever. Basically, just be as detailed as possible. Help yourself out. Help your team out. And consistency is key. So if you're starting to write messages, find sort of a format that works for your team and stick with it. But that's where you would just put that. You just declare it with the message keyword. So following that, we sort of get into the contents. This is the actual meat of the rule. Like, what are we actually trying to look for in the packet? We've sort of set all the foundational aspects up, but now we're actually going to look for what's in that HTTP traffic that we care about, or whatever protocol. This is the building blocks. So this is the actual bytes that we're trying to detect, and this is where we want to be unique. We want to be specific, but we also want to be, sort of loose in the sense that maybe we want to catch some variance. So really, you just want to try and find, it's kind of a continuum of not being so specific that if someone just changes one little thing, you're going to miss and be false negativing, but you also want to be specific enough that you're not going to false positive on everything. These contents can be represented as ASCII, hex, or a combination of both. And then following your contents there, we just have some rule metadata. So essentially just some good housekeeping stuff. So a signature ID, it's a unique ID for that rule. So it's a really easy way to identify the differences in the rules there. So that way you don't have duplicates, things like that. You can include a revision number. So when you initially write your rule, you can give it a revision number of 1. And then if you were to make any changes to it, I'd suggest bumping that revision number up just so that way you sort of are all on the same page of what's happening with that rule. Did anything happen to it? Was it a false positive and you had to add some stuff, whatever? And then you can give it other things too, like a class type. You can add references, things like hashes or URLs, like if there's a blog post that you wrote a rule from, you can stick it in there. Again, this is really useful for if your rule fires and you're trying to figure out, wait, what was that rule about? Why did I write that? And you can say, oh, cool, it was from this blog or it was from this hash, and I can go on VirusTotal and say, oh yeah, that was this thing. So it's more just helping yourself out. But that's the basic format of an IDS rule. What?
The revision number of the signature is super important to us as someone who provides a lot of rules out. Because sometimes we'll get a false positive report and they'll be like, yeah, this rule, it's just kind of generating all these alerts and you guys should probably go fix it. And we look at it and we're like, what revision of the rule are you on? They'll be like, oh, our rule says revision 4. We're like, we're actually on revision 36 of that rule, so you might have a problem. Make sure you're getting the latest rules, and then it'll get back to us when you get that new rule set.
Yeah, definitely super important. We have some rules that are based around like we track Tor, all the different Tor IPs, and stick those into rules, and that's obviously updated a lot. And so if someone's a couple days behind, then it's a whole new slew of IPs, and so they're like, wait, we're missing all this stuff. It's like, well, what revision are you on? But yeah, cool. So again, now that we've kind of covered that basic IDS rule format, let's look at that traffic one more time. And now let's start picking out some things. So we see a post method, right? That would be a good content to choose. HTTP post is important here. We have a pretty interesting URI string, generate.php. If we're looking at what we think is a ransomware, that's probably indicative of some naughty behavior. Really interesting user agent string. And we have this public key sort of variable down in the HTTP client body. That host name is pretty interesting, but why don't we want to really include that in a rule? It can change. Yeah, it's one of the easiest things to change. So we definitely don't want to include those things. We want to include the things that we think are unique to this sort of traffic, but aren't going to change as frequently. So if we wanted to express that in an IDS rule, it would kind of be set up like this. You just say content, and then you stick your content in there. Pretty straightforward. Now we can kind of take this one step further with what we talked about with the protocol-specific keywords. So we have these different buffers, right? So if we wanted to set this up in an actual rule sort of format from start to finish, we would say alert, protocol HTTP. We have our home net talking to an external net. So we have an internal client talking to the internet. Like letting them know, hey, I'm infected with this ransomware or whatever. And then we just sort of list out our contents there. They don't have to be in any specific order in this case, but that's kind of how that would work. And then we just have our metadata there at the end. So for HTTP specific, which we write a ton of rules for, we have a lot of different what are called buffers. So essentially when you look at that HTTP traffic, every single part of that is sort of ripped out and put into a little bucket. So the HTTP method is just that post, get, head, whatever. And they're just put in these little buckets, and we can just match in that little bucket instead of trying to match in the entire packet. So it makes it really, really efficient. Essentially what this does is it makes our rules super efficient, which helps the sensor out. So the more efficient our rules are, the less problems we're going to have with our sensor as we inspect more and more traffic. So if we assign these buffers to the contents that we just picked out, this is kind of what that would look like. So we have a content of post, and that's in the HTTP method buffer. So Suricata is only looking right here for post. It's not looking down here. It's not looking in any of the other header fields. It's only looking right there. So again, super, super specific and really efficient. Again, kind of continuing down, we have the HTTP URI buffer. So it's only going to be looking in the URI string, so after the method and then before the HTTP version. The HTTP user agent, so we're only inspecting this field right here. We're not even inspecting the actual header name, so we're just inspecting what comes after it. Whoops. And then public key equals, which is down here in our HTTP client body. So that's what's being posted to that server. So again, very efficient. That's kind of the key here. So then if we rebuild our rule with the buffers intact, that's then what that looks like. So that's the same kind of rule that we just looked at before we dug into that, but we've just sort of built it out. Does that make sense? Does anyone have any questions there? Yes? Yep. Yeah, good question. So he's basically saying, are these matching individually or all together? These are all like basically and together. So it's like Boolean logic and it's all and. So we're looking for a content of post as the method and generate.php in the URI string and that user agent and that value in the client body. Sure. Yep. Exactly. Yeah. So if they change the user agent or something, yeah, we're hosed. But that's kind of the cat and mouse game we play. But yeah, good question.
Can I answer that? Of course.
Yeah, one of the things we'll do is sometimes if we have a malware like this where they're being just really kind of cheeky and they're putting the name of the malware in the user agent, sometimes we'll write 3 or 4 rules for the same activity because we figure they're going to change it once they start noticing that they're being super dumb. So maybe we don't use generate.php for the URI. We have one rule that does the just the user agent, another rule looking for the generate.php in the public key. We'll write a couple of rules so that we have some backup rules in case this starts firing. This is that, okay, the pointer. That is data at thing that I talked about. That looks like weird. So this basically says that there's no data after the .php and the HTTP URI buffer. This is replaced by ends with. That's one of the new things we have in 4.1. So that's going to make this a little bit more readable.
Yeah, absolutely. And that's one of the cool things about, oh, sorry, question?
If you use a similar thing to do, let's say you're concerned about ransomware and you use the weird user agent thing, use that to whitelist certain user agents, for example, and then is there a way to set up a rule that's like a wildcard for everything else?
So one thing if I understood correctly, I mean, one thing we could do is negate certain user agents. So we could say like, we could say content bang Mozilla, right? And then that would basically tell the engine to not inspect any packets containing a user agent with Mozilla. And then wildcarding, no, but we have PCRE. So you could put a regex in your rule. The only downside with regex is it's really inefficient. So it's going to make the engine work really, really hard, especially if it's like a loose regex or have a super strong other content matches. But yeah, so you could wildcard in that capacity. Cool. Sweet. As we go on and through this project, we continue to add more and more keywords. Again, the name of the game is efficiency, and one of the cool things about Suricata being open source is we can basically work with Victor and the rest of the team and just say, hey, it'd be really cool if we could do this. And they're like, yeah, sounds good. And then like next week, there's a pull request for it. So it's really, really fun to have that like immediate feedback loop and make it a lot easier for us as analysts to write rules. So one example of that is something called HTTP header names. So what that does is it basically parses out all the header names and puts them into a string separated by hex 0D, hex 0A, so like a new line carriage return. So it's really useful for tracking the order of headers as well as the presence of certain headers. So like back in the day, we would have to write a regex to basically say, okay, at the beginning of the headers, it's going to be the host header name and then user agent, and basically go from start to finish in that order. But it was a regex and it was really inefficient. I mean, does anyone really like writing regexes? No.
It's okay if you do. It's cool.
How it works?
It's awful. I'm surprised I'm not insane yet for how many PCRs we had to write. But no, but this is really cool. So then it parses it out, and now it's just a string. So not only is it easier to just sort of put together in a rule, but it's also a lot more efficient. We're not doing PCREs, and that's the name of the game. So it's cool. So it's pretty neat, some of the features that we have in store. These are some of the other ones that came out recently with the 4.0.1 sort of release, and then it's just kind of adding to that. So essentially, we're just ripping out more and more headers and allowing us to match on those more specifically. Cool. So that was HTTP, but let's talk about DNS. So DNS can be really important. We don't like to rely on DNS kind of rules just because they're kind of like fire and forget, and then you have like a domain that's been killed and now it's in your rule set and it's just kind of wasting cycles. But they can be really useful if let's say there's a report that comes out about some APT. They didn't give you any samples, but maybe they gave you the domain names. You can just write a bunch of rules that at least can alert you to say someone tried to talk to this domain. We should probably throw their computer in the trash. So instead of just relying on the UDP protocol, we have a DNS protocol keyword that we can use. So this does both UDP and TCP-based DNS queries. And again, it's port agnostic. So we don't have to say only look for traffic going to port 53. We can say look for traffic on any port. And that's really powerful because again, it just allows for flexibility and efficiency. And then we also have what's called the DNS query keyword. So essentially this is just ripping out whatever domain exists in that request, and that's what we're looking for. So it's really easy. So this is kind of what your standard DNS query looks like in Wireshark. So we have a bunch of flags here that just explain sort of how that request is being made, and then we have the actual thing we care about here, which is the domain we're looking for. So sort of back in the day, we had to write rules like this. We're using alert UDP. We're talking on port 53. Our contents included a bunch of those flags, so like all this hex. We're doing positional modifiers saying those flags need to be in a certain spot because that's what we know about the DNS protocol. And then here's the actual domain. Again, those aren't periods, but they're actual, it's showing the length of the different parts of that domain. Really frustrating, really kind of annoying, right? It doesn't make a ton of sense. Wouldn't it just be easier to write the domain name there? Well, yeah. So that's kind of what we get. So this is how we can do it now. We can say alert DNS, and then we can just say basically on any ports, because we can parse any ports. We just use this one keyword, DNS query, and then we give it the domain name we're looking for. And that's it. So it's a lot more efficient, and it's also a lot easier as an analyst to write these rules. This is also something that could really easily be automated in that case. What's up?
I was going to say, if you look at this rule and the ports and whatnot, we have home net on any port to anything on any port. Any ideas why we wouldn't use external net there for a DNS rule? Exactly, yeah, because a lot of enterprises, a lot of places have internal DNS queries that'll resolve things internally, so we don't want to miss out on that. We want to make sure that our rule fires on it in all cases.
Awesome. And another reason, just going back one more slide, why this way kind of stinks is it also opens up the door to a lot of false negatives. It turns out not all DNS resolvers are following the RFC, and so sometimes these flags won't all be there, or they'll be in a different order or something, and it causes problems. It makes us sad. But if we use the DNS keyword, we're all good. So it's pretty neat. Again, we're just trying to make things faster and better for everyone in this case. Your sensor will be happy, and your analyst will be happy. So let's also talk about TLS in that same sort of situation. So TLS is kind of tough. It's a blind spot for pretty much any sort of network traffic unless you're doing man in the middle, which is awesome if you are. But until TLS 1.3 is like fully enabled, we can see quite a bit of stuff, including things like certificate information, all that kind of stuff. We kind of have this like ongoing feud with Let's Encrypt. I think it's really cool. I like encryption, but I also don't like giving away free certificates that can't be revoked or taken down if they're being abusive, like malware or phishing or any other evil stuff. But anyway, we can do stuff with SSL and TLS. We can write rules for it. We can actually still do something on the network with it. So this is sort of what your standard certificate exchange looks like in Wireshark coming across the wire. So we have here basically from the external server passing down the server the certificate to us. And then this is sort of what that looks like broken out in Wireshark. So we have a serial number and we have sort of the subject or part of the subject. This is really what we want to focus on when we're looking at these requests and when we're looking at rules. So the TLS protocol, it's like DNS, it's like HTTP. It's port agnostic. So if there's some sort of weird activity on a random port, we can still detect it if we use the TLS protocol keyword. Again, super powerful. You can just write a generic rule, looking for like TLS activity that's not on port 443, and that's probably strange. Why is there a certificate being exchanged on a weird port? Things like that. But there's also a lot of keywords that we can work with, and we can basically parse out that entire certificate, rip everything into a little bucket, and just look there when we build our rules out. So the most important thing, or one of the more important ones that we use is called TLS subject. So anything in the subject of that certificate, we can write a rule for. Same goes for the cert serial. So if there's a specific serial number we want to track or detect on, we can just basically rip that serial number out and use it in a rule. And then on the other side of it, on the outbound request in the SNI, we can also grab the domain name there and basically detect the request for a certificate from a server. This can be useful if the actual external server is down and we just want to detect that your machine was trying to connect to it. Similar to like a DNS rule. So this is the old way. This is kind of how we had to write rules back in the day. We still had the TLS keyword, but we didn't have the buffers. So we were able to still parse out TLS on any port there, but we had to use the raw hex bytes. So sort of reminiscent of what we were looking at in the DNS side of it. So here we have, this is the certificate serial number, and then we have this 5504OA in hex. Essentially that is the OU, or the organization part of the certificate subject. And we're doing, again, these positional modifiers. We're trying to tell the engine, hey, look for this here, look for this there, because when we break out the certificate, we know these things are in these specific locations. But again, kind of a headache. Who wants to do math? Math is boring, right? So with that, this is the new way. So we're still using the TLS protocol. We're still looking on any ports because we're using that protocol. But then what we're able to do is use the TLS cert serial keyword and then just give it the certificate's serial number. Really straightforward, really easy. It is in hex, that's just how the certificate serial numbers work, but it's just a little bit more thought out. Similarly, we have then the TLS cert subject keyword, and then instead of doing that hex in the positional modifiers, we can just say, hey, the organization equals default company LTD. Really straightforward, really simple, and just a little bit less of a headache. So again, it's more efficient, and it's just a lot easier as a rule writer to take care of business when we're trying to write rules to detect this stuff. So when we talk about rule sets, we mentioned our rule set, the emerging threats rule set, a couple times. We have an open rule set, so this is free. Anyone can use it. I think it falls under the same license as Suricata. But yeah, essentially anyone can go to this URL, hit it, download the rules, mess with it in your network, do whatever you want with it. And then we also have a pro rule set. So it's basically a paid rule set. You have to pay for it. It's essentially the same thing as the open rule set, but just a lot more rules are a part of it. Kind of the difference there is when we write rules that we think are going to have a large impact on the community as a whole. So whenever there's like maybe an internet-wide incident, things like WannaCry, that kind of stuff, and we have coverage for that stuff, we push it to the open rule set so anyone can have access to it. If people in the community contribute rules to us, so like if you're an analyst at your organization, you find some cool malware, there's not a rule written for it, and you write one, and you send it to us, we'll push it back out to the community, and we'll thank you and say, that's awesome. But then the pro rule set is more like what we do day to day. So we're the ones finding the samples, we're the ones reversing them, we're putting in a bunch of work there, so that it's a little bit more expansive, it has a little bit more coverage, but that one costs money. And it's not a ton of money, but it's per sensor, so it can get expensive. Similarly, Talos, Cisco, those guys are the other main sort of rule set provider. They don't write rules for Suricata, but their rules will work in Suricata, just not as well. Yeah. And then they also have a community rule set that operates on sort of a different sort of schedule. Basically, as their rules get older, they become free. And then they also have a paid rule set as well. And then at the bottom, there's some companies that do offer Suricata-specific rule sets. Attack Detection, it's like a Russian organization that writes rules. They're on their GitHub. They do a lot of like CVE, vulnerability research stuff, which is cool. But then CrowdStrike and SecureWorks also do Suricata-specific rule sets, but I think they both cost money. They don't do any free stuff. But just ways to get some Suricata-specific rules. So there are some cool NSM projects that do use Suricata. So these are kind of like all-in-one solutions that sort of come pre-configured sort of on a VM, and you can just drop them in and play with them. So Selks is a really cool one. A couple of guys we work with sort of manage this project. It's Suricata with Elasticsearch, log/Kibana, and then Sirius, which is like a rule manager. So that's pretty cool one to play with. Security Onion, I'm sure a lot of people here have heard of this one. This includes Suricata, as well as a bunch of other different network security monitoring tools, Bro, etc. Rock NSM is one. I'm not super familiar with this one, but it does include Suricata, which is pretty cool. So cool. So community-wise, again, we're open source. We're very into the community. We're into the idea of giving back. We want to basically engage the community and have the community engage us with this. We're kind of all in it together. So we have a couple different ways to contribute. On the emerging threat side of the house, if you're writing rules, if you're dealing with our rules and we're causing problems, this is one way to hit us up. We have a mail list. It's open. Anyone can just join it. And we just do signature discussion there. If you're dealing with Suricata stuff in general, if you have questions, if you have problems deploying, setting it up, compiling it, dealing with rules, whatever. We also have the OISF Suricata mailing list, so the OISF users mailing list. Again, that's open. Feel free to jump on that, interact with us there. On Twitter, these are all the different Twitter handles for the OISF Suricata specific and emerging threats specific. And then IRC, if anyone's in IRC still. We're hashtag Suricata on Freenode.
Are you going to ask if we have a Slack? No, we don't have a Slack. We're going to save you the trouble of joining another Slack room. One of the things I thought was really cool in Suricata in Prague, in our yearly kind of conference, there was like a 2-day, 4-hour section where everyone there could go and see what the roadmap is for Suricata. You could see what features everyone's working on. You can raise your hand and say, it would be really cool if we did this, but a little differently. And like it was 4 hours of really awesome discussion with people that just use Suricata, and I thought that was great. Really, just Suricata is a huge community, and everyone is really open. So if you have questions, if you have ideas, by all means, put them out there. It's pretty unlikely that you'll get flamed for anything. We're all pretty nice guys. Can't say the same for Jack, but yeah. But yeah, no, seriously. I mean, we're as much a part of this as you guys are, and we just want to make everything better. So if you have suggestions, ways to make it better, let us know. So just some upcoming events. If any of this stuff was cool to you or resonated with you, we have SuriCon, which is our annual Suricata user convention. It's in Vancouver this year, which is pretty cool. It's just a 2-day conference. It's pretty small. I'd say it's similar size to
I guess this kind of crowd. But it's really cool. If you're using Suricata, if you're an analyst using it, whatever, it's a really great way to interact with other people there, interact with the developers, and yell at them and say, hey, make it better. That's a great way to do that. We're going to be doing a 2-day training there on how to write good rules, similar to the one that we're giving this weekend, if that was interesting for anyone. The developer training is a thing, kind of talked about that, and private training. So if you guys are using Suricata a lot, that's one thing that we can do is come on site and help out and make everything better from that perspective. Feel free to reach out. That's all on the website there. All right, and that's about that. Any questions? Is anyone? All right.
Regarding your DNS rule, how do you correlate that with traffic that went to the domain in question? DNS request to a bad domain is one thing, but if that request came from a DNS server inside your network, how do I go find that person who really made that DNS request before we had another DNS?
Yeah, so the question is, when you have an internal resolver and the DNS request appears to come from the resolver, how do you go about finding the person that actually originated that request? I've had to do this a bunch of times, and really you want to have good logging on your resolver to see who actually made the request. There's nothing in Suricata that's going to find that for you or tell you that. It's really, and I've had situations in networks where there have been like 3 different resolvers that it's went through. It takes a whole afternoon, man. It sucks. But that's kind of the way you got to go by the logs on the DNS resolver.
Theoretically, it's maybe a full record of traffic going out to that.
Could be. Could be, yeah. Yeah. Good question. Yeah.
On your GitHub repository, how active is that? There's a lot of work that such a source web you want to add something to the project. How active is it?
So the question is, how active is our GitHub? It's very, very active. If you want to contribute code, there is a code guideline and whatnot. All of our Redmine, our ticket system, is open, so you can see all the things that we're working on. If you wanted to volunteer to contribute something, you can do that. We're really just open if you had questions about it, particular things like what could I work on? We have lots of ideas depending on your experience level. If you write a lot of Python, there's stuff you could do in Suricata Update. If you're good at C or Rust, we are looking for people to do that, and we are hiring too. So if you wanted to do part-time, full-time, remote coding for Suricata, we do have the ability to pay people and whatnot. So.
What if I wanted to just like sort of use firewall packet configuration, how easy would that be to do? Download on the computer?
Yeah, absolutely. The question is, like, how easy is it to pull down Suricata to mess with it in the lab? Super easy. Just grab it. We have pre-built binary packages for all the common OSs that are out there. You can build it from source for whatever you need to do. Yeah, there are a lot of guides on the Read the Docs. Again, we're going to make all these slides available on our Twitter. We'll post it out with the DakotaCon hashtag. And then our Redmine has older, more interesting setups for some more obscure operating systems and whatnot. So yeah, pretty easy to pull it down and get messing with it. Any other questions? No? Okay, we'll be out at our booth over there. We have a whole bunch of stickers and some stuff. If you want to come out, say hi, ask any questions, we'll be there all day, and then we'll be here tomorrow for the trainings. And we'll hope to see you again. Thank you. There's our Twitter if you want to follow us. We post stuff about network packets. Good job, dude.
Damn.
Is that yours? No, that's theirs here. Yeah. You want to just run over to the booth in case anyone is right there?
Test, test. Okay. Cool. Well, I think I'm going to actually just start. People can roll in as they get out of the other session if it's running late or whatever. Can everyone hear me fine with just the podium mic? Like, if I have a choice, I'd rather not babysit a microphone. So anyway, my name is Michael Liedema. Here to talk about blockchain in hopefully a way that isn't pure marketing, because that's kind of been a problem of late. So I'll do my best. I'm a DSU grad. I graduated in '05. Currently living in Spain, where I have a small company there. We do research and development of these things. So if you need research or development of those things, there's the plug, there's the website. I also joined the Intense Coin team. It's a cryptocurrency project. It's a not really cryptocurrency. It's called a token coin. We'll get to it, doesn't matter. They are trying to build a decentralized VPN based entirely on blockchain. So just joined that not too long ago, so that's pretty cool. Anyway, hype, I lied. There's some hype up front. In case you haven't heard of blockchain, we have to get the hype going so that you can pay attention to the rest of the talk. Otherwise, you might not care from the go. Anyway, where exactly is blockchain on the hype cycle? The Gartner hype cycle comes out every year. This is where it was last year. So we are officially in the peak of inflated expectations, descending into the trough of disillusionment. Not exactly what you want to have for your upcoming product or technology, but that's kind of how all products and technologies go. They go from early adopters up to everyone thinks it's the best thing in the world, and then reality sets in, and then somewhere along the road it settles into an actual product that people use and then kindly ignore in 10 years because it's so normal. Money-wise, this is the market cap as of yesterday. Bitcoin's sitting at about $148 billion in market cap, so kind of worth paying attention to. The second one is Ethereum at $53 billion. If you rewind a couple of months, those numbers were much, much more impressive, but also totally fake. Yeah. Can I what? Switch to VGA. Oh, sure. Yeah, switch to VGA. Yeah, no problem. I have all the dongles, all of them. Let's see if this works. Oh, jeez. It's going to come back. Yay, analog technology. Okay, VGA, let's give this a shot. Okay, does that work? Cool. So Bitcoin, $148 billion, $53 billion for the next one, lots of money. Where does that sit in relationship to like common publicly traded companies? So well, Apple is at the top, 750 billion in market cap, then 579 for Alphabet, aka Google. So that seems like it's not really in the same league, but these are the top 5 public companies in the world. These are all companies that are valued less than Bitcoin right now. Small companies like Boeing, McDonald's, Broadcom, Starbucks, UPS, Nike, Siemens, Comcast, Bank of China, Unilever. Small little companies, mom and pop shops that can't quite compete against the new technology that's only 10 years old. Anyway, investment is also going crazy because there's money to be had, so there's money to be spent. Last year it was coming up at, it's 900 million, coming up on $1 billion of investment in blockchain, and I love the term blockchain adjacent startups. So that's common investing with the goal that eventually those companies will develop a product and go public, and then they hit the stock market, and then the value inflates, and they can cash out and make money on their investment, and the ROI is 50 to 1 or something, typical Silicon Valley expectations. unicorn style levels. But we don't need that anymore if you have the ability to have your own currency that is regulated by yourself, much to the chagrin of many governments around the world. So you can actually do, instead of an initial public offering, you can do an initial coin offering. And you can sell shares of your technology directly to people who want to give you money. So you get a bit of cryptography in exchange for real money. So who would do this? Well, obviously a few people have done this. These are the top ICOs. The first one is 257 million that they raised. The next one was 232 million. The website obviously didn't know how to do commas, so I'm sorry about the readability on the numbers. So that's quite a bit of money too. So what we're seeing is that based on deal volume, so the amount of deals that are closed, there's still more deals being closed in venture capital than in ICOs. But the amount of money coming in from those initial coin offerings is massive. It's it's about 78%. It's 4/5 of the money coming in is coming in from ICOs. Last month, it was 1.4 billion in ICO investment. So last month. Total, it's about 8 billion. Why? That's what I'm here to try to explain. So that's the hype. That's why everyone's going crazy that there's this money being thrown around for blockchain. What is blockchain? Does anyone know what blockchain is? It's like, yeah. Or from a quote from a movie that I really like, or do you just have like a throwaway line so you don't look stupid in a conversation? You're like, oh yeah, that's that, and then you fall off and hopefully nobody asks you any more questions. So blockchain versus Bitcoin, those get kind of mixed up interchangeably. A little disclaimer too, throughout the rest of the presentation, I could be well actually'd to death up here. I'm trying my best to explain this in a way that is going to work for a general audience that may or may not have experience with it or care about certain aspects of it. You could talk for an hour about mining just by itself. So you can well actually meet later in the hallway and we can talk about it. Blockchain is a technology. Bitcoin is an application. They were invented at the same time. Blockchain was invented in 2008 for use in Bitcoin. It was a means to an end. Bitcoin solved a previously unsolved problem and created a new product, Bitcoin. This problem was thought about for a long, long time, and we're going to go through the problem. But this was the breakthrough. Blockchain was the thing that solved this fundamental problem that enabled Bitcoin to happen. And the thing that Bitcoin enabled or created was decentralized electronic cash. Electronic cash that you could send peer-to-peer without an intermediary. So you had true peer-to-peer payments for the first time without both people having to trust someone. You have electronic payments online if you send your money to PayPal and trust them, and then PayPal sends your money to someone else, hopefully. So you have an intermediary that you both trust. This allows that transaction to happen without an intermediary, and that's the magic. So it's really a breakthrough technology. It can record transactions accurately without a central authority between all these distributed entities. So the technology itself is actually decentralized consensus, and it opens up an entirely new way to think about building network applications. If you don't have to build this central authority, or people don't have to trust that central authority, well, what other kind of applications could you build? This is the interesting question. May sound a little familiar. It's like inventing email and creating the internet as a byproduct. And just, wow, we can send messages to each other. This is fantastic. What else could we use on this? I don't know. It seems kind of useful, though. I mean, maybe over the next 30, 40 years, we'll find some other uses for this gigantic network. So that's kind of where we're at. Super early days for blockchain. The general problem that they solved is called the Byzantine generals problem. Who's heard of this or seen it like in a textbook or a paper or whatever? Okay, so I'm going to do my best with lovely graphics to try and explain this problem. This is the problem that they solved, and this is the core thing to understand. You have 4 generals or ex-generals surrounding a village or a fort or a castle or something that they want to take over. And there's no way that they can like get on a conference call and talk to each other and say, what are we going to do? So they all have their own plan at the beginning of the day, and they have to make a plan for tomorrow. So they think, well, it's 8 o'clock, 7 o'clock, 10 o'clock, whatever. We need to somehow communicate with each other and come up with a plan, but we can't all talk at the same time. We can't all meet. We're located in physically separate places. So the first one writes a little note and sends it on a rider and says, we're going to attack at 8. And the guy looks at it and says, oh, yeah, sure, 8, sounds great. Sends it on to the next one on his rider, and the other general, sorry, I'm not seeing my preview. Okay. Yeah. So the second general that they send it to says, I don't want to attack at 8, I want to attack at 9. So he crumples up that piece of paper and writes 9 o'clock. Then sends it to the last guy, and the guy says, oh, 9 o'clock works for me, that's perfect. And they send it back to the first guy, and he says, well, that's not the plan. So what happened? Like, did they all want to go at 9, or just one guy, or nobody? Or like, did somebody kill the rider along the way? Nobody knows. So how do you solve this? How does blockchain help these generals? How do we make an analogy to what blockchain does to what this general problem is? Still have the generals, they still have different plans. First guy writes his message, says, we're going to go at 8. Now the thing we have to change is how the messages are created. Creating a message always takes a fixed amount of time. This is the important part. If you want to make a message, it's got to take 5 minutes. Sounds arbitrary, but that's the rule. If you want to write a message, it has to take 5 minutes. So the guy writes his message. It could be on a piece of paper. Maybe he has to carve it out of a chunk of wood or something. And he writes his plan and who he is and who it's to. And then at the end, he draws a picture of a horse. And he sends it to the next guy. And he looks at it and reads the whole message and sees that there's a picture of a horse. So he knows that it took 5 minutes because it takes a while to draw a picture of a horse. And he goes, okay, yep, sure, 8 o'clock. That works for me. Now this is where we change things. We don't reuse the message. He doesn't send that slate onward. He doesn't change it and just like add his name at the bottom. He creates a whole new message that takes another 5 minutes. And goes into the tent and writes the message, and it takes 5 minutes. He comes out, and the rider knows that he has created a unique message because it took 5 minutes. And he's waiting outside the tent for the guy to write his message. He comes back out, creates the message. He writes it in the same way. This is for the next general from this general. Draws a picture of his horse, and then sends it on its way. We change the way messages are distributed by always appending all messages to all previous messages. So we don't just send the latest message, we send all the messages that have ever been sent in this communication. So now the second guy gets both messages, and he knows that each message took 5 minutes to create. And he sees 2 pictures of 2 distinct horses, and so he's pretty satisfied by all that. He agrees at 8 o'clock, he goes into the tent, and he writes his message for 5 minutes and draws a picture of his horse and sends it to the last guy. Now the last guy knows that all 3 generals want to go at 8 o'clock, and those are all valid messages. And he says, well, I want to go at 10. That's stupid. 8 o'clock's way too early. Crumples up all the messages or destroys them, and then he goes into the tent to write the final communication. Well, after 5 minutes, he's interrupted. And so, are you done writing the message? Well, not really. I've only written this one. Well, send that along. The last guy gets only one message. He knows something has gone wrong. So those previous messages have been thrown away. They were attempted to be altered. If the last guy had 20 minutes to make his message, he could forge all the other messages in time and create consensus that way, but he can't. He only has 5 minutes to create a message. All the messages have to come along, and so the last guy knows something's wrong. Something has happened. We don't have consensus. We don't all agree on what the state of this plan is. So how does that relate to blockchain? It seems a little arbitrary, drawing pictures of horses and carving things into slates. So each general in this analogy is a node on the network. It's an instance of a decentralized application. So it's a piece of software running on your computer. That's the general, sitting there on the network. The network itself is the rider going back and forth. That's pretty straightforward. Every message that is being sent, we call that a transaction. Not a message, it's just a transaction going from A to B in some way. each block can contain multiple transactions. So don't picture the guy carving out a single sheet of paper. Picture him like slapping the picture of a horse on the front of a book, like a whole bunch of messages that he's done writing. Then he does the 5-minute operation and puts them together and sends it along its way. Each of these blocks or chunks of messages must be created in a fixed amount of time, and that's called the block time. For Bitcoin, that's 10 minutes. Every 10 minutes, we make a new block. And this proof of work, that's the guy in the tent carving out the message or drawing the picture of the horse. Some sort of effort has to be expended to create the message. And it's some sort of effort that you can easily verify. So it shouldn't take 10 minutes to create and 10 minutes to verify. That would be horrible. It should take 10 minutes to create, and you glance at it and go, yeah, that looks like a picture of a horse. Difficulty, we're trying to create a fixed amount of time. Some people are better at drawing than others, so maybe they can draw really quick. So then you don't say, well, draw a picture of a horse. Maybe you have a whole fleet of generals and they're really good at drawing pictures. So you say, well, draw 4 horses. It slows them down so that they still take 5 minutes to create their messages. So enough about drawing horses. Mining, not every general wants to draw horses, right? They're not going to sit in the tent and draw the horses themselves, so they would outsource that to somebody else in their crew that really wants to do it and maybe pay them money to do it. This is the mining function of blockchain. Somebody has to do this effort to create these messages and provide validity to the network, so since you're expending effort and electricity probably, you should be rewarded for that. Because if no one's doing that function, the network stops. That's the thing that keeps the network running. So it's rewarded. Anyway, and blockchain, pretty straightforward. It's a sequence of blocks. You're chaining the blocks together. Every time you append a message, you have a bigger chunk of material. And the important part is you have this big chain of blocks, this big sequence of messages, but everyone has a big sequence of messages. All those messages are distributed to every participant in the network all the time. So everybody has this information, and then it's usually called a public ledger. So a ledger is like in accounting, you have your plus balance and your minus, or your ins and out, credits and debits. You have this ledger of things that were transacted, and there's a specific order to them. Everyone has a copy of that ledger. So everyone has a copy of every transaction and every message that was ever sent. And that means that every node in the network can know the truth. So if somebody starts lying, everyone could say, that guy's a liar. 51% of us know that this is wrong, so ignore those messages from this other node. So that's how we get consensus. Everyone knows the truth all the time. They can all talk to each other all the time. So if there's no central authority, how do we have user accounts? If you want to sign up for a service online, you have to sign up for a service and register an account, and then they send you a confirmation email, and you click on a link and it goes to their site and it activates your account. Who does that function in this distributed, decentralized application? You don't. That's the answer. You don't create accounts. You just create public and private keys. So common, PKI infrastructure, you create a pair of public-private keys, and you use those to interact with the network and other users on the network. The public key is something like your username on the network, on the blockchain network. That's what people send messages to. So if you've seen donate, donate Bitcoin buttons or sections on a website, it's like a really long string of random characters, it looks like. That's the public key, and that's their address on the network. That's their username on the network. The private key is like your password. Well, actually, yeah, it's like your password. So just to think about those two pieces of information in that way. You can generate them independently of the blockchain and, on your computer privately. You don't need permission from anyone to interact with the network. You create your username and password by yourself. So I sign messages to you with my private key. If I want to send you a message, I sign that message with my private key, and I address it to your public key. And I put that message into the network. And then everyone validates the message integrity with my public key. So everyone knows that I sent the message and only I could have sent the message, or at least only the person that has my private key. So there's confirmation from everyone in the network that the message that I'm sending is valid. It also confirms that only I could have sent it. Put another way, in Bitcoin land, your public key is used to deposit things, and your private key is used to withdraw things. So this is where the term wallet comes into play, and I don't really like this term. Does anyone have a wallet or has run a wallet, Bitcoin wallet? Yeah? Okay, so the wallet is participating in the Bitcoin network, and it's downloading all the transactions so it can know the truth of the world, right? The true state of the Bitcoin network. And that's how you participate on the network. If you don't have a wallet, you can't know what's going on. So this is a horrible term. Once you get out of Bitcoin land, it's a really bad way to call it. It's just a pair of keys. It's not a wallet. It's not like a physical wallet that you have on your computer. If anyone has your keys, they have your Bitcoin. So it's not like your wallet is a physical thing that you could lose. You only lost your keys. If you lose your keys, you lose your wallet. If you have your keys written down on a piece of paper, like if you'd actually take the big long hash that's your private key and write it down on a piece of paper, you can destroy your computer. You can set it on fire and throw it away. And you get a new computer and you could type in the key that you wrote down, that's your private key, and you could get your wallet back. So it's not in a physical space, it's just a piece of information. Has anyone heard the story, the super famous story of the guy in England that mined a bunch of Bitcoin and threw away his hard drive? Like it was worth hundreds of millions of pounds. And so he started hiring people to go search through landfills to try and find his hard drive. Yeah. Keep your private keys safe and remember that you have those Bitcoin. Also, 50 Cent just realized he took Bitcoin donations for an album like 5 years ago. And he discovered he has, I don't know, $5 million in the bank in Bitcoin after everything went through the roof. So, keep track of these things. They can change in time. Here's a good question. If you're writing software, if you're going to build something new, is blockchain even applicable? And this is where the hype really goes crazy. Everyone just puts a big layer of blockchain on their product or at least their marketing pitch. And they just put that icing on there, and then they hope somebody comes and invests in their company. Kodak did it. Said, we're going to make blockchain digital rights management for photos or something. And they got investment. Some coffee shop was just called itself blockchain something something, and they were suddenly super famous. So everyone's doing this, but should you, as an engineer? Do you need a data store? If you don't need to store data, you don't need a blockchain. If everything is stateless and just kind of is like a processing application, you don't need blockchain. If you do need to store data, do you have multiple writers? If it's only one, who cares? Don't worry about it. Just write to your file and call it good. But are there multiple concurrent writers? Can they trip each other up? That's important to manage. And then, do the transaction order matter? If it doesn't, then you don't need it either, because the whole problem that it solves is ordering the transactions for multiple writers in a disparate network. And then, are there actually any untrusted participants? If it's some internal product for your company and it goes between components that you've engineered, 5 components that you've engineered every single one of them, there's not really any untrusted participants, so you probably don't need to do it either. And if there are untrusted participants, could a third party be used? So try and think of a situation where a third party can't be used, a trusted third party. Sometimes it's kind of difficult because we just trust, Facebook's in the news. Oops. We, sign up for this account with my other credentials, and that's a great mediator of private information, this other company, and I don't care because it makes my life easy. But what happens if you couldn't trust a third party, and what would a situation be like that? Anything international, if you're dealing with regulation between countries, there is no one higher than each country individually. So if this country has an idea of the truth and this other country has an idea of the truth, there's no mediator. So those are two untrusted parties. There might be diplomatic consequences or whatever, but if you're talking about, let's say, a car registry in between different countries, or roaming, roaming between different mobile providers, they need to settle their bills somehow. So if one person lies and says, oh yeah, your customer was on my network and made like $10,000 worth of calls, pay me. There's no one to mediate that dispute. It's between two telecoms that might be government owned anyway. No one steps in, so they need to have some sort of untrusted validation. That's where it comes in really interesting, or it becomes very interesting. I didn't mention one thing, because this is the current problem with blockchain, scalability. How many transactions per second do you need? I hope it's not very many. It's very slow. As you can imagine, you have a gigantic network of thousands and thousands of nodes that all have to reach consensus every step along the way. Or the majority of them have to reach consensus along the way. And they all have to process every single transaction. Every single one. So where are we at? Visa can do about 24,000 transactions per second, which is a lot more than the fastest blockchain competitor. Ripple was designed to be very, very fast, and it can only do 1,500 per second. And it falls off pretty quick after that. Bitcoin's way at the end with 7 transactions per second. So don't build anything too finely grained or too, doesn't need to be too reactive. But there's an important thing to keep in mind. Visa was founded in 1958. It's had a while. They've had some time to figure out how to make this really fast. Ripple was invented 6 years ago with a technology that was only available 10 years ago. So, cut them a little bit of slack. They'll probably figure it out. This is the major focus of blockchain innovation right now, is how to scale this. How do we maintain consensus, provable consensus, and still scale it up? Right now, they use proof of work. Proof of work is drawing the horse or calculating the answer to a math problem. But they're also working on proof of stake, which is if I have a bunch of money in this currency, I'll just bet you that my answers are correct. So I'll take a chunk of my coins and put them in a place that I can't touch. And if I keep providing false information to the network, other people verify it and say it's wrong, then they're rewarded for proving that I'm lying. So I'm betting you money that I'm telling the truth on my node, basically. And if I'm not, my money goes away. So there's no need to do some massive calculation. You're just betting that people are not going to lie and lose their money. And then they're rewarded for also participating in the network. So that's an interesting one. Proof of stake is very interesting. Proof of authority is kind of starts to smell like centralization. Like, well, these guys are good and these guys are bad. So who says that they're good and bad? Starts to get a little shaky. But of course, things get a lot quicker if you can just trust a few nodes to generate positive and verifiable information. There's a couple ways you can scale. It's just like a database. Instead of having every node process every transaction every time, only the even-numbered nodes process the even transactions, and only the odd-numbered nodes process the odd transactions. So there's a 100% gain there. You can do it again. You can make it more fine-grained, but at some point, it only scales linearly. It's not like a solution, really. There's also research going into off-chain operations, where you have what they call an anchor of truth inside the network. So let's say I'm playing checkers. To play checkers on a blockchain network would take a long time. So I make a move, everyone confirms the transaction, then I move this checker to this square, and then everyone confirms, okay, yeah, and then the other player is free to go and they can make their move, and then everybody in the entire network processes that move. So that would not work right now. So what they do is say, I'm going to make a move, and then we're both going to sign each other's moves off of the chain, in between us two. We establish a peer-to-peer connection. We talk to each other. Every time you make a move, I use a key and sign it, and then you sign my move, and back and forth, and you make this state channel. So you have the sequence of events that's in a channel that progresses through many, many, many different states. Every change in state is signed along the way, and then it goes back to the blockchain and somebody verifies it. So that final state is sent back to the blockchain. There's a reward function for somebody to verify that, yeah, all those moves make sense, all those signatures make sense, and then they confirm that it is a valid sequence of transactions. So that's how you can speed things up, where not every single step of the way is so important to be recorded in the blockchain. There's also side chains. This is called, oh, sorry, the last one's called Raiden, and in one of the projects I'll talk about in a bit, Ethereum, they call that Raiden. The research is going into that. Side chains, that's called Plasma. Basically, instead of having one chain that everyone follows, you can like make a little side chain over here and do a bunch of independent operations. It's kind of like a state channel, but it's formed as a blockchain independent of the other one, and then it loops back in and connects back to the main chain. Also a validation function on that to make sure that everything is, that nobody's lying in that situation either. So Ethereum. Who's heard of Ethereum? Wow, that's pretty good. Awesome. Yeah, Ethereum is pretty cool. So I'll talk about it a bit. This is actually, the next section is completely on Ethereum. So Ethereum Foundation grants, just to show that scalability is like a big deal. These were awarded on the 7th. And look what the top money went to. $1.5 million for scalability, another 100,000 for scalability, another 50,000 for scalability, another 25 and 25. So the gross percent, or the majority of the money in these research grants went for scalability, with the top prize, $1.5 million, compared to the next one. It's 3 times over the next one. So lots of money being put into scalability research. Ethereum is cool. Ethereum is pretty cool. If Bitcoin was blockchain 1.0, where we just proved the concept and showed that it worked and got people excited that this was a possibility now, that this problem had been solved, that was in 2008 and launched in 2009. Ethereum seems to be something like blockchain 2.0. It was proposed in 2013 and launched in 2015 by a guy who is, by every recording and interview with him, it's just staring into someone who's very, very smart. And then you rewind the video and listen to it again because, wow, okay, you figured that out by yourself. Very cool to watch the introductory video of him proposing this idea too, because it's one guy from Canada, and like a group of researchers now are working there, and it's turned into this gigantic engineering force. There's tons of money being put into it because they're innovating like crazy. Bitcoin only implements really, really basic scripting, right? Send this amount of this coin to this person with this key, with this signature. So people were trying to innovate within that space and trying to like kind of abuse those parameters to implement other applications on top of this network. And they kept running into limitations. It wasn't designed to do much. And so then they would make a copy of the code, start a new cryptocurrency that did a specific other thing. And this happened over and over and over, dozens and dozens of times, to implement one specific application. So this guy said, what if it just let you program inside the blockchain? Instead of having the blockchain be a fixed set of functions, why don't we just allow languages to be compiled and loaded into the blockchain and executed? So they have Turing complete languages. Languages, not just one. They've come through 4 now: Mutan, LLL, Serpent, and Solidity. And Solidity looks pretty approachable. It looks like JavaScript. That little bit of code is implements your own cryptocurrency. You allocate coins and you can distribute them and you can transfer them between people. And you only need, that's not the entire thing, but let's say 100 lines of code. And in 100 lines of code, you can implement your own cryptocurrency on top of the Ethereum network. So this was huge. And they, of course, had to come up with a name for it. Distributed apps, dApps. I don't know how you say it. I don't think anyone's ever said it in public, probably. But decentralized applications. Suddenly, you don't need to build your own infrastructure. You don't need to come up with, how do I build my blockchain? How do I get people to join it? I need to have scale before it'll even process anything. It's there. It's running. It's a virtual machine. It's a decentralized virtual machine that you can program for. And they call these things smart contracts. So little chunks of code that you can stick up in there and interact with. And since they're provably secure, or that consensus will be reached on them, you can do things, simple things. You can like vote over them. You could do insurance contracts over them, health records, establish provenance on a piece of art or a piece of well, a piece of meat. Actually, I'm going to talk about cows in a bit. Anyway, royalties. People implement distribution rights for music on top of it. You embed a little bit of cryptography into songs and have it ping back and automatically transfer money when the song is used. Things that are, you know, goodbye paper pushers. If they think that deep learning and sensor technology is going to get rid of all the drivers in the world, this might get rid of all the bureaucrats in the world. This might get rid of every office visit and like, well, you have to sign this paper, but you have to bring this form, but you can't be a copy. It's got to be a stamp. All that could just gone because you can automate this stuff and it's trustworthy. So the life of the cow, right? Let's say there's no central authority in your state, or you don't trust the federal one, or you're trying to go between two countries that don't have any agreement with each other. You can put a tag on a cow when it, you know, comes into this world, and you put a QR code on it and scan it, and you scan your ID and you say, this cow belongs to me. And then you take it to the veterinarian and you scan the cow and your ID and the veterinarian and get a record that it went there, right? That gets put into the blockchain. And then I sell it to somebody else, so I scan my ID and the cow and the person that I sold it to, and they transfer me the money, and they can show that I sold it on this date, and they take it to another veterinarian, and they can take it to an auction, and it can be transferred to another person, and then it could be brought to a slaughterhouse and put into little packages and sold in a supermarket. And I can take out my phone and scan a QR code on that sirloin, and it'll tell me all that stuff. Like, you could build that, and you wouldn't need any infrastructure, you wouldn't need any permission from anybody to build it. You could just build it. You could just build the mobile app and the app that runs on the veterinarian's computer that keeps synchronizing all the blockchain state and the auction house, and you would have this amazing tracking ability with absolute trust between all the participants, and you don't need anyone to give you permission to do that. So what if it's not a cow? What if it's a car? A car is significantly smarter than a cow now. How now, Brian? I did not mean to do that. Oh, wow. Anyway, a car could be integrated with the blockchain too. So I could rent the car from my friend and send him a payment, and his phone can send a command to the car to unlock itself, and then my NFC radio on my phone could start the car. And I don't need any permission to build any of that either. I mean, you need a CAN bus integration, and you need a mobile app, and the payment gateway is there, payments are solved, transferring the temporary ownership or possession of the car is solved. You could even tie in an insurance contract that's activated because they know that I'm going to own the car for 72 hours, and they could activate an insurance contract, and then when I'm done, you could have like prorated insurance for the 14 and a half hours that you own the car. You could do all sorts of things like that. So yeah, unregulated, going to take a while to get that clarified as to how much of this is possible and how much isn't. But I think what is the quickest way to say it is TCP IP is a communication protocol. You can transfer information back and forth, but blockchain is a value exchange protocol. So if I have, in the same way, like if I pull out 4 $1 bills, I can only give them to 4 people. But if I have like a digital picture, I can give it to a bunch of people. And I could say like, well, I only sold it 4 times, the digital picture. I own, only 4 people in the world own this digital picture. Well, do they? I mean, they could just make copies of it. There's no way to say that. You can't increase the value of your digital photograph because you just promised that you only sold it a few times. But with blockchain, you could show that you only sold it that many times. And so it gives value to the things that you're sending back and forth. Utility tokens. This is kind of where I'm interested in. I think I think you'll kind of see the utility of them. Haha, the utility. Namecoin. This is decentralized DNS. It's an implementation of DNS that's completely decentralized. So nobody can take over, nobody can put false information. It's a trusted DNS that's distributed all over the world and can be relied upon to resolve names. Pretty cool. This has got the best name of the group. The Interplanetary File System. That's a decentralized file storage or content delivery network. So I don't have to trust anyone that I send this file up there and no one's going to manipulate it or prevent access to it or somehow restrict it. Or it's decentralized, trusted. It's tough to scale because can you imagine running YouTube on a decentralized blockchain right now? Pretty impossible. Everyone would have to have every copy or a copy of every video ever uploaded to YouTube. So this is not going to happen this year anyway. Enum, this is a phone thing. Normally I talk about phone stuff. I do a lot of cell phone stuff. So enum is a way to resolve a DNS name to a telephone number or a telephone number to a DNS name. So this is a decentralized enum. Enum failed because there was no central authority. There was no one in the world that could say this phone number maps to this DNS address. It was too, you had to trust too many people, or you had to pay for it, or whatever. It was fundamentally flawed. But this fixes it. It's decentralized enum. This is exactly what they wanted in the first place. The one that I'm working on now is decentralized VPN. It's faster than Tor, right? Because you're not going through a bunch of nodes. It's just simple VPN, but it's peer-to-peer. And then there's an incentive to run the exit node because you'll get paid. You'll get paid in these tokens for running the exit node. You can also control the traffic that goes through the exit node, have a little more granular control. And then this is the cool part to me. If you can't afford VPN service, well, you can fire up a computer in the corner and have it start mining the coins for this service. And then once you have a few, you can establish a connection to somebody else running a wallet, running the daemon, and pay them to exit through their connection. So you can earn VPN connectivity by just mining some coins and spending it on the network. I'm going to go back to drawing horses now, because this is kind of an important point. This proof of work algorithm, there's a bunch of them, and the one that's chosen for Monero and IntenseCoin is a fork of Monero is Kryptonite, whatever. It's egalitarian mining, meaning when you're drawing these horses, when you're mining and solving mathematical puzzles, you're not drawing horses, you're solving math problems. That's called, usually it's measured in hash power, how many hashes of a specific problem can you perform in a second. And the network stops if you don't have any hash power. So people are incentivized and they're paid to provide it. You can do these calculations on the CPU, on a GPU, or on an ASIC. ASIC is an application-specific integrated circuit, so it's a custom-built device that just does these hashes. So what you're talking about in order of magnitude is CPU, maybe you can do hundreds of hashes a second. GPU, maybe thousands, tens of thousands. ASIC might be hundreds of millions. I mean, it's designed to just do that. It's not a general-purpose computer, it's designed to just do that. So there's been a lot of work on making these algorithms ASIC resistant. So there's the SHA-256 was Bitcoin, not ASIC resistant at all, very easy to program into a device. Script made it so that it required too much memory, so you should probably use at least a GPU, we can't use an ASIC. ETH hash is another memory, it really wants to use a lot of memory. Kryptonite, that's the one that uses a whole bunch of like low-level CPU cache. So if you don't have a bunch of CPU cache, it's going to run really slow. So it doesn't run fast on GPUs either. It doesn't run fast on ASICs. Now they're working on ASICs. Ugh. And the problem with, well, why don't you want people to run ASICs and why don't you want them to earn more money on your network? Because they can gang up and do like a 51% attack. This whole thing depends on consensus of the majority of the nodes. So if the majority of the hash power that's calculating the answers to these problems is lying to you, the whole network breaks. Because I can say, well, he transferred all of his Bitcoins to me. Look, most of the network thinks he did. And then everyone says, well, I guess so. I guess he did. And then that becomes part of the blockchain and it's permanent. You can't delete it. So there's a lot of work trying to find ASIC resistant proof of work algorithms. Something that runs the same speed on a CPU as a GPU as an ASIC, and that lets people participate in the network, which distributes the hash power over a wider chunk of the participants. That was the original idea of Bitcoin in the original white paper, which, by the way, read it. It's probably one of the most concise explanations of how blockchain or how a new technology could work. It's 8 pages long. I mean, it describes the entire thing in less than a dozen pages. It's incredible. But the original idea was that every node can participate, and one CPU means one vote. So it wasn't designed that one person could have 1 million votes. It was designed that one CPU participating in the network has a vote, and that's it. So now, this isn't hype. This is like, I'll put on big rose-colored glasses and talk about how wonderful everything is. Is this how the web should maybe be? Like, maybe it should have been like this from the beginning. Web 1.0, everything was static. You made your GeoCities page about your favorite band, and you had your 19 animated GIFs going back and forth, and it was static. And you went to fan sites, and you're like, that's cool, that guy really likes that band. And then Web 2.0 had JavaScript, so you could program some stuff, right? And Ajax happened, and all of a sudden, like, the Flickr uploader never changed the page, and wow, you could do all this stuff without the page reloading. It was very interactive. But somebody had to provide all the infrastructure for that, so you ended up with a bunch of walled gardens. So you didn't have like GeoCities with all, everyone's little personal space. Everyone is on Facebook, and you can't see what they're doing unless you're on Facebook, and all your content belongs to Facebook, and it's only available on Facebook. And if you share a post, you can only share it to the people that they will let you share it with. And if you want to share it to more people, you have to pay them more money so that more people see your posts. It's horrible. So they provide the infrastructure, which means they extract value from your personal data to pay for the infrastructure. If you didn't know that, I mean, that's what they do. Otherwise it wouldn't be free. You're the product. They take all your information, everything that you do, and they study and they sell it to ad companies, and they try and get you to buy stuff. That's it. So what if there wasn't any need for a entity, a company, a publicly traded money maker to own the infrastructure? What if it was decentralized? What if it ran on everybody's computer all the time? That would be pretty cool. And then you would control your information, right? You could choose how you want it to participate, how anonymous you want it to be. That'd be pretty cool. There's a couple that have already started working on it. Steam.com is like medium.com, but you're paid for content and comments. So if you write good comments or good content, people can upvote you, and upvote automatically transfers a micro sliver of coin to your account. And if you write intelligent comments on other people's posts, you also get transferred a little bit of coin for doing that. Earn.com, it's like LinkedIn, but you're paid to be contacted. Like, what if LinkedIn would make it possible for headhunters to pay me $5 if they wanted to send me an email? Right now, they pay LinkedIn for the ability to send me email. Well, that's crap. I mean, you literally pay for InMail, you pay for a subscription to be a pro user and a headhunter, and then LinkedIn gets paid every time I'm bugged by a stranger who wants to talk to me that I don't know. This inverts it so that I would get paid $5 if you want to talk to me. And it's almost like they predicted it. This is an unused HTTP error code from 1999. It was never implemented. Payment required, 402. 404, everyone knows, right? Not found. Same one. Like, we found the content, but you didn't pay us. 402. Now it's possible. Before it was impossible to do, but now you could. You could implement a 402. Anyway, super early days. If there's any problem with it right now, it might get solved. I would guess it gets solved. It's the very, very beginning of everything. There's even a new one called Hashgraph. It's not blockchain. It's orders and orders and orders of magnitude faster. It doesn't require any proof of work, but it's patented and owned by a private company because they're smart and they want to make money. I mean, surprise. But what could that be? If it's not 1,500 transactions per second, but like 250,000 transactions per second. and it doesn't require electricity to be used needlessly calculating the answers to pointless mathematical puzzles. Like if that whole part could be removed, what would that mean? That would really change everything. So really early, who knows what's going to happen? Blockchain might not be, I mean, you might be talking about blockchain now like it's amazing, and then in 10 years like that was pretty naive first shot at this idea, but it proved the point. So anyway, that's all I have. If you have questions, please ask me and I will try my best. Not for you. No, you don't have to pay $5 to talk to me. 3, it's fine. The question is there any changes coming up to computing technology in general that would render this like useless or make it easy to count? Yeah, well, you're always betting against public key cryptography, like, and there's a significant motivation to find a loophole in public key, right? If you found the loophole to that, that's I think the total cryptocurrency market cap is 350 billion, all of them together. So that's significant motivation. Every bank transfer is done in, PK. Every interaction with a website is public-private keys. The one question is quantum, which I am not qualified to talk about at all. But there is research going into being quantum resistant because a significantly powered quantum computer could calculate the answer to the fundamental math problems behind public key, private key infrastructure. So that's the only one that's kind of on the radar, is like quantum computing. But
yeah, I've been reading a lot about supply chain management using blockchain, but how does that connect to scalability?
how does supply chain management match up with scalability? It depends on your granularity of your supply chain. If you're measuring every single, piece of electronics on a board, on a PCB or something, if you're scanning those at the speed that they're being soldered onto the PCB, that might get tough. But if you account for the fact that it's not scalable at that level, then it does solve the problem. Between like a manufacturer in China, a shipping company in the Middle East, and a sales company in Europe, and a returns department in the United States or something.
Well, it's like verifying that organic is organic.
Yeah, there was verifying where something came from, verifying that food has actually been farmed responsibly. Yeah, at some level, if it's not a computer program you're talking to, you have to trust the interaction between the person inputting the data and the farm that's reporting that it's organic. There still has to be like an on-the-ground truth check to see if it is or not. But that's a problem with everything. That's a general problem. But as far as once you've established that, then proving that this company scanned this box of bananas and sent it to this other shipping agency, that's solved without requiring anybody to, or without demanding any trust from any of those companies involved. After it's been put in the box and sealed, then after that, your trust is established. I think it's pretty interesting. There was a ICO that got made fun of a lot because it was like bananacoin or something.com, and it's just fun to make fun of it because now they raised a bunch of money based on the idea that they were delivering bananas in a responsible way or reliably trackable way, something like that. Okay, you can bug me in the hall or whatever if you need anything else. So thank you. Oh, thanks.
I never heard a good explanation of blockchain.
Was it? Okay, good. Because I spent 80% of the presentation on the Byzantine generals and like how do those tie together. Because I've heard it kind of hand waved over a bunch of times. Well, it relates to this old problem, and we solved it. Like what?
It basically all relies on decentralized API. So those certificates work in the perfect world. Also, the world people will have public keys. Doesn't that mean I have to actually keep track of all these?
No, because it's all one to one. There's more advanced stuff coming out. Like if I have your public key, and you have your private key, and you have my public key, and I have my private key, right? Then we can establish trust directly. We don't need to. And there's also just making sure I didn't leave one of these jobbers behind. There's also a form of public.
What? I cannot. I can use HDMI.
Do you have an adapter for it?
Yes, I have an. No, I don't have that.
Oh,
Is there nothing?
I gotta call my boss quick.
Okay, yeah,
So
that's
when we
all I
stream it,
have.
We can't use the HDMI.
Oh, I'm pretty sure there was an email that said I could use HDMI, so that's why I brought an HDMI adapter.
Or just maybe it'll work for this. Or try plugging in quick.
Is there an HDMI cord? Oh, it wasn't working before. Okay.
Because we can't get
It
it on
flashed.
the stream for YouTube on there.
Oh, you can't get it on the YouTube stream? Can we do the stream with just the video and without the slides? Because I kind of need slides, so... Oh, thank goodness. Okay. See if we can get this going.
Here in there somewhere. Thank you.
Yep, no worries. There we go. Guess I'll start, maybe? I guess I should start? Yep. Okay. I'm gonna go ahead and start presenting in a second. Are you guys able to? Sorry, if you don't mind. Thanks. Okay. So thanks for going ahead and coming to choose to come see my talk. My name's Megan Roddy. I'll be presenting on strengthening your SecOps team by leveraging neurodiversity. To start with a bit about myself, I'm currently a graduate student at Sam Houston State University in digital forensics. I also have a bachelor's in mathematics and a few certifications in cybersecurity. I currently work at the Texas Department of Public Safety as a cybersecurity analyst while doing security consulting on the side. And I have 21 years experience, like many speakers at these conferences. My experience is 21 years in life. And most relevant to this talk, I have Asperger's syndrome. So for this talk, I'm going to give an outline of an introduction to what my talk is about and why I give this talk, inform you guys of the problem I identified and why, and basically the reason that I'm giving this talk, the evidence of other companies who have already discovered what I'm speaking about today, and the solution and how to adapt to as an employer or a coworker of an individual that I'm talking about. I like to start my talk with a couple quotes regarding neurodiversity. The first one is from Steve Silberman, an autism advocate. He says that one way to think of neurodiversity is to think in terms of human operating systems. Just because a PC is not running Windows doesn't mean that it's broken. A similar quote talks about sports and how sports teams, they typically don't hire or take on athletes just because they're the best overall. They don't need all great runners or all great kickers. They hire a team with a variety of skills so that together they can do the best in their field. The same thing applies, and the reason I'm giving this talk, the idea behind what I'm speaking on, is that you need a variety on your team, and that means bringing in individuals who think differently than yourselves. So the individuals I'm talking about today are a group of highly productive individuals who have an extreme attention to detail, are logical and calculated, passionate about the work they do, and hyper-focused. Specifically, I'm talking about individuals with high-functioning autism. Here I like to give a disclaimer because there's a lot of talk in the community about how that we don't want to be generalized into a bucket. So my talk is not to tell you that every single individual on the autism spectrum should be in security and nowhere else. You may have a second cousin with autism. Don't tell him to drop out of art school because I said that he's good at security. So this is just, it's a subgroup of high-functioning autistics who are interested in the field and good at these skills. And though I'm speaking about high-functioning autism, I title my talk Neurodiversity and not Autism because these same themes apply to what I'm talking about with neurodiversity in general, is that we need to be accepting and bring in these individuals into the field. Whether it's autism, bipolar disorder, depression, anxiety, it all applies in diversifying your team. So the problem I'm approaching with this talk is that there's a high unemployment rate among high-functioning autistics, despite the fact that only under 5% of individuals on the spectrum are considered to be mentally disabled at the point where they are unable to hold a full-time job or any job at all. There's still a high unemployment rate. 95% of individuals with autism are either of average intelligence or above average intelligence, and so are fully capable of holding a job. So why are they not employed? It comes down to the social and behavioral disabilities associated with high-functioning autism. Basically, we're weird. I like to go over a few of the things that I personally experience and that you may see other individuals with high-functioning autism experience. First is I typically talk at a very loud volume, even in personal conversations. This tends to annoy people. It frustrates people, especially when they're trying to work on something and they can hear me from across the room. I'm told to be quiet and to use my indoor voice as you would tell your 5-year-old child. It's frustrating. I don't realize I do it a lot of the time, but I understand how it can frustrate people, especially after they point it out. I also am very blunt when I speak to people. If I believe something is the truth and it is solid fact, I will tell you. I actually have a new example. I used to give a different one, but this weekend, before I came into town, my fiance was sick. I think he has like bronchitis or something, but he's stubborn and won't go to a doctor. And so he saw me the other day, we were having dinner, and he was like, are you okay? Because I guess I was looking upset. I said, that cough is really starting to annoy me, so I'm just gonna go away. So I'm very direct with what I say. I'll say things that offend you, like, because he probably was not happy. I was telling him his sickness was a nuisance to me. But typically I don't think about what I say and how people will interpret that. So that can turn people off, and really I don't understand that what I'm saying is inappropriate in the context and that some things are to be kept to yourself. This is a picture that shows kind of one of those weird behaviors I'm talking about. This is a picture of the jeans I own. They are all the same brand, same size, same style, same color. I am very hypersensitive to certain materials and fabric, and I don't like shopping. It stresses me out. So I found a pair of jeans I like, and I bought as many pairs as I could because it would be a disaster if one pair was ruined and all of a sudden I had to go on the journey of finding a pair of jeans. So this is that kind of weird behavior where you're gonna think I'm strange, and you know, just as human nature, you now kind of don't want to associate with me. So this also points out a characteristic from individuals with autism is that there's a lot of times hypersensitivity is associated. You'll find a lot of individuals who fluorescent lights make it difficult for them to pay attention at work, or in general, fluorescent lights are basically painful. Fabrics, tastes, any sort of sensory processing can be very much intensified, and that's one of the things that makes it difficult to work, or it results in us exhibiting strange behaviors. Despite these things, there are companies who have been able to look past these social and behavioral disabilities and realize that individuals with autism provide invaluable skills to the industry. I want to start off with some statistics, an overview of companies, employers in Australia who have employees on the autism spectrum. And the overall consensus was that these individuals were benefiting their team. They had above average performance and exhibited some of the characteristics I mentioned before, the attention to detail, the quality, and the work ethic and passion. They brought in different skills that they found that neurotypical individuals did not have. And they reported positive adaptations in the work culture. The individuals were adjusting fine when given the right environment to thrive in. And there was no significant additional cost to the employers. That can be a stereotype. It's something that's wrongly assumed, is that you're going to incur all these costs for all these adaptations and the things that you have to do to follow ADA laws and all that. But they found that it's not really true, especially in the case of the autism spectrum. So the first company I typically bring up is actually a collective of companies, specifically SAP. I like their logic behind why they started their Autism at Work program. They looked at the statistics that 1% of the world was on the autism spectrum. So in their minds, if 1% of the world was on the autism spectrum, then why shouldn't 1% of their workforce be on the spectrum? They sought out to, by 2020, have a matching population of autistic individuals at their company as they do in the world. And so they started their Autism at Work program. Behind them came Microsoft, New Relic, HP, and many more technical programs technical companies that have these programs. These programs seek to help the individuals adjust to working a full-time job, along with helping the managers and coworkers who have not been in a situation where they've had to regularly interact with individuals with autism learn how to properly do that. This is one of my favorite examples, is the Israeli army. They have laws in their country that When you turn 18, you must serve a few years in the military, the Israeli army. And the Israeli army is known as a strong military force. And what was happening was there was many high-functioning autistic individuals who would turn 18, and as all their peers were going off to join the military, they were getting letters exempting them from service and saying they can stay home and not worry about it. But the thing is, these individuals wanted to fit in with their peers. They wanted to serve their country as many of their peers were doing out of high school. So seeing that there were a pool of people who did have the mental capability to work full-time, they decided to start an individual unit called the Visual Intelligence Division, or Unit 9900, in which these individuals spend their entire day sitting in front of computer monitors and comparing satellite images over time. They do this to help the ground forces identify potential threats that have emerged in the environments. For example, maybe there was nothing on the road was clear, and now there's some weird mound over in the corner, and they can notify to watch out for IEDs or other explosives and booby traps that may have been planted. Additional things, military forces moving that are typically stealthily. These individuals were able to go long periods of time. They also have an extreme attention to detail, so they would notice small changes that their neurotypical employees typically would not. The best thing that came out of this is that the commanders of this division decided that they didn't want to fully segregate, and they didn't need to fully segregate the autistic community, and realized that all it took was a little bit of learning about how these individuals needed to be led, and they were able to move them into the general population military forces and put them in typical military roles. So it was a learning experience for them. At first they thought that this group of individuals would be so different and so difficult to manage that they needed to segregate them. But when they realized there's individuals wanting to work in other roles and that it really wasn't that hard to manage them in this place, they decided to make the change, and it's proved well for them. Lastly is, again, several companies and a group of companies that employ autistic individuals specifically. Aspertise is a French and Canadian company that provides big data, security, and programming services to various other companies. They say that for a different and innovative vision of IT beyond the traditional perimeters with very expert profiles and closer to the machine. The logicness and calculated thinking of individuals with high functioning autism is valuable to them, as they are closer to the machine in the sense they think more like a computer than a neurotypical individual would. They're not the only company that does this. You have Specialistern, Non-Parietal Institute, Specialist Guilds, Empirical, DakotaCon. All these companies either employ a large workforce of contractors with autism to perform IT services to other companies, or they bring in individuals with autism, train them up in security and IT, and then help find employers who are willing to work with them and get them jobs, and help those employers learn the differences in managing neurodiverse employees. JP Morgan is another example of a company with an Autism at Work program, and they said that after 3 to 6 months, the autistic workers were doing the work that took 3 years worth of training for other individuals, and they did it more productively. This is an example of quick learning and productivity at work. When they were put in the right environment, they were able to do the work of multiple employees. So what do I think the solution is? I believe the solution, when it comes down to it, is awareness. We need to learn to not look at individuals with high functioning autism as individuals with a disability. Though they do have a disability, what we should be focusing on as employers is not their weaknesses, but the challenges they bring to the company. Just as you would with any neurotypical employee, you're going to think about what their strengths are and how you can utilize them in the company. You should be doing the same thing with neurodiverse employees. You should be thinking about how they are an asset to your company, not all the things they're not good at. And the truth is, yes, you will have to adapt to the employee. These employees are different and think different and behave different than neurotypical employees. But like that Australian study said, it's not going to be a cost to you. And really, it's pretty simple. I'm going to give some examples of this so you can learn how simple it really is. So to start off, I want to say, forget how you manage neurotypical employees, because it's not going to be the same. I provide this example of something I've actually experienced. Let's say that at your company, your employee comes to you with a great project idea, and they want to have it considered, they want it to be a new project implemented. Well, currently there's a limit on resources, bandwidth. It's really not a great time for your company to take on new projects. You need to get what we have off our plates and then go. To a neurotypical employee, you may say, that's great, let's reapproach it when we have more resources available and we're less busy. The thing that stresses me out about that sentence and makes it difficult for me to process is I find less busy to be an ambiguous and subjective phrasing. What I may consider to be less busy is typically a lot what would be very busy to a neurotypical individual, because I typically can handle a lot more work and tasks when I'm working. So saying less busy, I find it hard to determine what you consider to be less busy and what a neurotypical person would. So I'm looking for more solid deadlines. I say, remind me about it in a couple weeks. For me, that means a date I can put on my calendar, a time to reapproach you and know that you're ready to be reapproached and you've told me that it's a good time. The timeline doesn't actually matter at this point. You can say 2 weeks, 2 years, 2 months, however long you need, but that solid date provides a lot more comfort than a subjective term in which I'm now having to take into account what you may be thinking, which is difficult for me. So as you can see, that was $0 extra that you're spending per month in your department, and it was a 2-word difference. There was nothing about that put a strain on you as a company or as a manager. It was just simply taking into account that a more solid deadline was needed. So at a higher level, what HFA employees need is structure and routine. They need clarity on what you need from them. They would appreciate patience and understanding, knowing that they don't know all the things they do that may be considered strange or inappropriate to a general environment. Understand that when I say something to you that offends you, there's a very good chance that I did not mean to offend you, and I thought I was just saying something that was obvious or fact, and that it wouldn't be taken incorrectly. By making these simple changes, what you will get in return is a highly productive employee, as JP Morgan said, typically twice as productive from what they saw. You'll get thorough work that's well done, and a dedicated and passionate employee that love everything they do in their job and are willing to work as hard as they can for the company. So some of the more specific things that what I like to do is I like to take what many people would consider weaknesses or disabilities or negative things affected with my autism and show how that can be used to your advantage rather than it being a disability and nothing more. For example, I get bored really easily. I also knock out tasks pretty quick. So when I get bored at work, I'm not the kind of person who thinks, well, I'll get on Twitter and just hang out until something else comes up. For me, in my mind, work is work, and so for those 8 hours, I'm doing whatever is assigned to me. Well, if I have nothing to decide, I get bored. I Google the word bored, and I just sit there and don't know what to do. It stresses me out. I actually have a more difficult time when I don't have anything to work on. But you as an employer shouldn't think of this as a disability. This is perfect for you. I write requisition orders and write procedures and do all of the tasks that nobody ever wants to do. I do the entire and other duties as required of the job description because I would rather do that than sit around and either do things non-work related or do nothing. So as an employer, this is not a benefit, this is not a disability or a weakness to you. This is a major benefit and the chance to have all those tasks that every other employee groans about completed with nothing said. Like with my thing about specifying time ranges and not using ambiguous phrasings and descriptions such as less busy, try and be specific with your instructions. If you need me to do something, try and guide me in the direction of what I need to do. Recently, I've been really frustrated with school from an academic perspective because schools don't always get it right. And working full-time, like working in the real industry, I've learned things are much different than with school. However, I think the reason that I always did school and enjoyed school was because homework assignments tell you what to do. They say click here, and then click here, and then do this, and then do that. They're very straightforward, and they're a specific set of directions. Building furniture too, that's always fun to me because it tells me what to screw in, where, and when. So in the same way, I find it easier to perform an assignment when I'm told what to do directly. Do this specific task. So I suggest that you try and do that within your employees. But also, I like to learn and grow from my weaknesses. So if my weakness is that I'm dependent on a specific outline and you need me to be more independent and take a more broad assignment and get into the nitty-gritty details of it and learn how to do it myself, teach me how to do that. Maybe slowly wean me off of the direct instructions and be like, well, you know how last time you did this, I want you to do a similar thing. And kind of teach me how I can learn myself to figure out the task without needing hand-holding the entire time. Because I don't want to be hand-held, but I also need to learn how to do it myself, as anyone would learn any other task. Another aspect of high-functioning autism is an intense obsession with basically anything. I had varying obsessions growing up. For a while, I really enjoyed like Guinness World Records and Ripley's Believe It or Not and had all the books and videos and loved researching that. After that, I moved to Doctor Who. I had an intense obsession with Doctor Who for several years, bought all the merchandise, the magazines, watched every episode like 20 times. So again, a lot of times I'm that weirdo who has the bedroom with all the posters and I'm obsessed and all I want to talk to you about is that specific subject. But employers can use this to their advantage because typically they need SMEs in a specific area. And you can assist these individuals in finding what their interest is and what they can be an expert in. Because if you encourage me to be an expert in a specific topic, I am motivated to learn everything I can in that topic. For example, if you needed someone who is really good at memory forensics because you found that there's a lack of memory forensics skills, send me some resources to memory forensics challenges, encourage me to develop those skills, send me to online CTFs that include memory forensics challenges so I can challenge my skills. And all of a sudden, that's my obsession. When I go home, I'm learning these skills because to me this is something I'm really interested in and I feel I'm good at. I want to improve my skills and then I want to show them off at work how I'm a master at memory forensics now. So that's the kind of thing where, again, strange thing, weird behavior, a benefit to the employer. My final point I make in my talk is that the most important thing you can do is something that honestly as a manager you should be doing with every single employee, whether they are neurotypical or have a neurodiverse disorder. What you should be doing is being a mentor. I find it particularly helpful to me as an individual who has a disability that I often don't realize what I'm doing, but I also find this important, as I said, to all employees. What I'd recommend is taking 30 minutes once every few months, going at lunch, sitting down with your employee one-on-one, and discussing with them what you've noticed, what they can improve on. Ask them what they want, what they think, what they've been struggling with that you can help them with. Have a real discussion about lines of improvement. A lot of times there's things I don't know I'm doing, and so it takes that few minutes aside where yes, I'm the center of attention basically, and you tell me that, hey, you've been doing this in the office, it's been making people mad, maybe we can readjust this behavior and how can we fix this? And I will fix it because again, I don't want to do things that are offending people or upsetting people, but how can I fix what I don't know? So this is something, again, one of the most important things on my list. I like to learn what I'm doing wrong so I can fix it, because though I may have an understanding employer now who's willing to work with me, I don't want you to be understanding in the sense that you ignore everything that I do because, oh, it's just a thing. Because what happens when I get a new job and that employer isn't as understanding, and now I'm doing the exact same things that I didn't know I'm doing and I'm being penalized for them. It's really not benefiting anyone. Whereas if you at the time are an understanding manager and you discuss with me where I can improve, then that's how I'm going to go ahead and grow and be able to move forward in life and be a better employee. My talk always ends up being shorter than I intend it to, so I'm hoping there's some questions out there so that I can keep talking for a bit. Anyone got any questions? No. Really the getting bored one was the hardest, because so the job I'm at now is actually my first full-time job, and I made at first, a lot of managers found it more frustrating than anything for me to be like, what can I do, what can I do, what can I do, what can I do? But then they soon realized, like, when I'm saying that, like, I will literally do anything. So like, well, there's this requisition order that I didn't want to file 3 months ago, so here's the paperwork. So that was really hard for me, because when I sit idle, I get stressed and then I get frustrated, and really it agitates my condition more than everything. So that was one of the biggest struggles. But again, my managers took notice of that, and they've learned that the best thing to do is to like have a list of tasks, kind of like back burner tasks that they can throw at me when I come to them and say that I need assistance. Any other questions? Yeah.
What would your advice be to a room that has quite a few teachers at university in it?
Yeah, so one, encourage them. That's a hard one. So it's really all about encouragement. I know a lot of times the students with these conditions can just get discouraged, especially, knowing that there is some struggles in the industry getting in when you have a disability and the way people look at you. So it's encouraging them to themselves find the benefits, and for them to learn why their condition is a benefit to them and how to leverage those benefits, rather than accepting that they have a disability and so they might not get a job and that sucks. So it's really about massaging, like making them realize, because before they can get their managers to realize, they have to realize themselves. So this first step is making sure they're confident in their skills and confident in their strengths and know what their strengths are, rather than focusing on their weaknesses. I find a lot of individuals come to me and say they're having trouble getting connected into the community, like the IT community. So the other thing is like pointing them in the directions of places they can network, because we're also in an industry where a lot of the times it's about the people you know. And so encouraging them to go to meetups and conferences and CTFs and develop those relationships in the industry can also help. Any other questions? Yeah.
Do you have any thought plan, or maybe there is growth already, but to develop a community within the IT community?
Yeah, there's the organizations that do help individuals get in. I haven't been able to really find a more social community focused towards that aspect. Obviously on Twitter, it's a huge InfoSec community, and then at the same time, I've discovered a huge autistic community. I love it if there's that overlap. It's a great thing that I'd love to do. Again, there's a lot of neurodiversity conferences. There's a lot of IT conferences. I think it'd be a great thing to put that together. There probably is a lot of us people who would be the attendees and the speakers don't have these social skills to do that, and so it's kind of hard making a social event through non-social people. So, but that would be a great thing that I'd love to see in the future. Yeah.
How would incorporating or making it most effective in like teams with collaboration?
Yeah, so a lot of the times a lot of the things that make it difficult to work with these individuals is they are weird. They do annoy people in a sense. So I piss off my coworkers all the time. Like, it's surprising they keep me around and still invite me out to the afternoon socials. But so the thing that is kind of a bi-directional relationship, they need to learn that, like, some of the things I do and say, like, I don't mean, and like if I offend them, I probably don't know I'm offending them. And so it's patience and understanding on their part, but me learning, it's also me taking into account that when they say something like, hey, that wasn't cool, like, I can't get defensive, like, and be like, oh, well, yeah, you don't understand, it's not fair, and like, blah, blah, blah. Like, so it's a bi-directional relationship of them understanding that things I say and do are some things that I can't control or don't know about. And me in return learning that the feedback they give me and the things they say to me aren't meant to make me mad, and they're not trying to be mean to me. They're trying to help me grow and socialize. And so it's also a lot about inclusiveness. I've been really lucky to have these coworkers who, despite me annoying them some of the times, they'll still invite me out to after work socials. So it's a lot about, the huge thing is inclusiveness, making sure that the employee doesn't feel set off to the side, and involving them in anything you do, just as you would with another employee. Yep. Any other questions? No? Okay, well, I really want to thank you for speaking, and it's really been great. If any of you are in the OpenSOC training with Recon InfoSec tomorrow, I'll see you guys there. I'll be helping run that, so it should be a good time. Okay.
I'm always worried every single time about it being too long, and it's always too short. Every time I read that, I always go back. Yeah. Yeah. No, yeah. It's really, yeah. Wow, I really appreciate you guys having this. Yes. My name is Jade, with Communications on Campus.
Where do you want like that?
And so we'll make sure I got this. I wonder if you have time for any extra questions.
Josh, are you okay?
Absolutely. Actually, I need to probably take a picture of you.
We just need to like, be not here. So.
For me, it's usually like, because I teach many classes, like, I'm going to do this new lab with 30 students. Wow, that was a shit show. That win is absolutely terrible.
We were very glad to
So,
hear the group size because there's enough that was like flying out here, not like one person sitting
yeah,
alone.
yeah, but not like
But not
this
like,
overwhelming
not like
number.
they hop on and all of a sudden all our servers die.
Yeah. Yeah.
Yes, definitely. Yeah, me too. I've never been.
It's a very big state.
Yeah.
Rocky for that. Yep.
Yeah, we're from the south. Yeah, it's like, oh, I love this, like, when we were in the other building, I was like, this building, here. And then, like, it got cold, and then, like, I don't
Oh, that's
get
right.
it.
Yeah.
This is why I went to school in Texas. Yeah.
This isn't even like cold.
Yeah. It's good because, like, summer's coming into Texas, and I'm going to complain about the heat and the humidity.
Yeah.
Then I can be like, but I'm not in South Dakota like I was in
Did it snow this morning?
Yeah.
Okay. I got here.
Well, I don't
it was,
know if
it was
it's
still.
considered snow, but people
It was
who are
probably
in snowy
enough.
cities. For us, it's snow. Like,
I got here. It's still dark out. So
I was born in Atlanta, but raised in Texas.
Oh. snag you guys just a PowerShell if there's something you need to plug in or you did?
We ran out of outlets.
Oh, okay.
Between like 3 servers and 3 switches and laptops.
He says, one would be good, two would be great.
Yeah, there's the students will be on a lap, so they can sit and learn the road and use it.
Well, all the tables will
Yeah.
have,
Yeah.
all the tables are powered too, so
Yeah,
it's
yeah, exactly. Yeah, students will be like that. Cool. Thank you very much. Yeah, you bet. Yeah, you guys have been a great help. Sometimes like inside conferences. Yeah. Well, we ran this before, like we'll go to conferences and like bring them a free product and like they'll get excited. It's so hard to get people like, we need this.
Like, they're so enthusiastic and love us, and it's so comforting that, hey, you have this, and you're like, yep. I'm like, oh, wow.
Hey, happy.
Yeah.
Have you guys like excited to have like just new cool stuff?
Yeah.
I mean, because usually people like don't want to come to South Dakota and show cool things. So
No, we're excited.
Wendy was talking about how she takes it.
there might be some sweet I know we have enough for minimum requirements, but yeah, we have every laptop the help desk has. So maybe we do, maybe we don't. I don't know. It was literally every spare they had.
Does this mic work? Okay. So I guess we'll get started. I'm Chuck Madraska, presenting over-the-wire tips and tricks for executing Python in memory. A little bit about myself. I work at a small cybersecurity company called Black Lantern Security in Charleston, South Carolina. Do most of the dev work there. Pretty big into Python. That's my main jam. Kind of a fanboy. And then if I'm probably known for anything, it's for drinking Guinness. Drink a lot of Guinness. Kind of infamous for taking 2 at a time right away. So go over a little bit of what we're going to talk about today. Why would you want to execute Python in memory? What can you do with it there? A little bit of background on Python importing, because that's probably the most important thing to how this is all going to work out. And then a demo of basically just a basic runner of just doing stuff in memory, some fancy importing, some scheduling stuff when you don't have access to things like a cron or a task scheduler on Windows, and then databases, whether it be some kind of file or relational database. We'll see some cool stuff there. So use cases, why would you want to do this? For blue team and red team, they kind of stand at the same side. One of them might be obfuscation. So if you heard Jared Lamach talk this morning, he talked about sometimes we just give away our source code, and in Python that's really relevant because it's a scripting language. Whatever you see is what you get. And so you're going to see exactly what people are doing if the source code is there, versus like if it's native code, you know, it gets compiled down into assembly or something like that. But that's useful for both blue team and red team. Blue team, you don't want an attacker to know exactly what your stuff does sometimes. On the red team, you also don't want the blue team to be able to read your code and see you downloading bad stuff. Blue team, again, one of the ways I've used it before is to actually patch stuff where I didn't want to write to disk. I just wanted to add new functionality to my program. So I had a little runner in there that would basically import from outside instead of writing to disk and importing from there, or doing, if you've used Python, some kind of pip install, something like that, I could just do it over the wire. Red team, again, you could update your own software doing that. Maybe you wanted to add new scanner functionality to your red team tool. And red team, another relevant one is you don't want to write to disk a lot of times because that's an indicator of compromise. You want to stop, or you might not be able to either. They might have it access controlled to where you could get your one little Python widget on there and you want to load more stuff in, and the only way to do that was through memory. So Python importing. If you've ever programmed in Python, you just see something like do anything cool, just import whatever the library is called. And how that actually works is there's 2 things called finders and loaders. And when you, it's how all imports work in Python. First thing it does is it tries to find where your Python script is coming in. So whatever you're importing, it's going to look through, first it looks through built-ins, and then it looks through site packages, anything you might have loaded through pip. And then third, the other one is just in your Python project, it'll look through there. And this is really important on order too, because if you name something the same as a built-in, it's actually going to load the built-in first and be really mad trying to debug why your thing isn't doing what you think it is. It's using some functionality from a built-in. So important to note on that. But finders don't, all they do is pass a spec to a loader. And a loader, all it's doing is it knows exactly where it has to load from now. It'll do certain things though to check to make sure it's not already loaded. It will tell it basically how to load it. In the memory one, I'll show you an example of why you have to tell it different ways, especially when we're going across the wire. Yeah. Okay, so I'm gonna go do a little demo here, show you some stuff. So it's something I cooked up. Basically, it's just a memory importer, and you can see right away we have something called find module, and basically we're gonna pass it what we're gonna name it. And this first one right here is actually gonna see if it's a built-in. Again, you don't want to step on your own feet doing this. And then on the next one, it actually making sure nothing on the site package either, because the loader is going to take care of that. Okay, so the loader is kind of the more important part when doing it in memory, and it's going to load some packages, going to make sure it's not there. But the big part right here is we're going to tell it to read from a URL to actually read the file across. And then again, if you had it already like a PyYC file, there's other modes you have to do for that. So this is just a really simple example of using that to load from a local server I'm going to put up here in a moment. It's just a package called neat. If you want to see what that looks like, all it's going to do is a class with a print statement. And the server, it's just a Flask server that's going to open up its directory, so any path you hit there, it can get the file from there. So if we run this, you see how neat is this? Pretty neat, I think, being able to do it across memory like that. And all it did, you see the server, it actually looks in that directory path for it's either going to look for a package or just a Python module. So in this case, it first went for the module or the package, and I couldn't find it. So it instead went to the next level of, let's just see if there's just a file called that, which there was, and it pulled over and executed. And so the next example of this, luckily in Python, you don't usually have to write your own stuff because there's awesome people out there who write stuff for you. And so there's actually a package called HTTP import, which does all that stuff I just showed you. You don't have to write your own finder and loader. If you don't want to, you can just use this. If you're using just HTTP, it makes you throw this up there. It has a context management for remote repos so that it will both load it into your namespace and remove it after you're done. Sometimes you may want that, sometimes you may not. Just you don't want namespace conflicts is one reason not to do that, or one reason to do that. And so you can see we can give it a list of modules to import. Again, we'll just tell it what URL to hit, and we have the server up. And these would be the imports you do to be able to access this. But say you didn't know the names or something like that, and you want to make it more dynamic, you could do a request across, get a list of imports, import them into some kind of dictionary or some data structure, and actually access them that way too, instead of using the namespace to hit them. So if we run this one, so again, you'll see repeated text because we did it both with the namespace and one without. So again, the neat one prints out how neat is this, pretty neat. Just to show you, the hello one is a package. So you can see we have this exposed over here and it has a file inside there. So sometimes when you see like the from hello import hi, hello is the package and we can import stuff from there. Caveats on this when using this HTTP import, it doesn't like when your package name is the same as the file name you're importing. So if it was from hi import hi, it would fail out. So just something to note if you do use it. And another caveat to doing this stuff in memory is it has to be Python files for here. You might be able to make a finder loader somehow to do it, but you think of stuff like shared objects or DLLs, those aren't going to work for this. So things like there's MySQL database has like a shared object for Linux, like you're not going to be able to load up something like that necessarily. But again, you can just see, okay, you got it in memory. We're able to load code across. And they're doing pretty simple things, but we'll do some cooler stuff a little bit. So that's just executing code. And then there's stuff like, what if you want to schedule something? A lot of times when you're building out something, you want to do something at a certain time. Usually you have access to something like cron job or task scheduler in Windows. There's a neat library in Python called schedule. It allows you to do schedule tasks. And again, so I was loading it off my server I have running locally, but you can also, go to GitHub or something. They have a nice magic GitHub function here, but all it's doing is getting to the raw content and pulling that file across. And so what we're going to do here is schedule something. As soon as this program starts, it's going to create a loop. It's going to check for any scheduled jobs and it's going to sleep a little bit. Then we have a little flag here that's going to load in new scheduled stuff from my server to tell it to schedule new jobs. But it starts off with just a 10-second job, and then the new schedule, when it hits, will add a new job called add a new schedule every 5 seconds. Again, this is loading it across from memory. So that's another cool thing right here. Because we're loading that schedule from GitHub, we can still use that even though we don't have it loaded on our computer, because we loaded that namespace into a memory. And so even though this one has no ID schedules on that computer, it will find out as soon as it tries to import this. When you saw the loader already looks for stuff preloaded, so it will know that schedule's there and it doesn't need to try to import it from here, which is nice because then we can actually use it in other scripts. So if we run this, you'll see it start adding jobs here. Again, there's one we already have on here that just runs every 10 seconds. And then there's one that we added that adds new ones every 5 seconds. So if you need to run like a scan every, you can create jitter and stuff to feed it different stuff. You can run it on certain days. The schedule's pretty cool for that. And again, doing this all in memory, so we didn't touch this, which is really nice to be able to automate stuff through a schedule and not have to talk to the OS or anything like that and give ourselves away. So that's kind of neat. Next thing is databases. So usually there's not too many things that do this, but SQLite happens to allow you to just pull in a whole database in memory, which is really nice. Again, think if you're like scanning something, you're scanning for hosts around you. You could just put it into some kind of flat file memory, but then it's really hard to both update that, dig out certain data you want for that. So we're gonna look at actually creating a database in memory. And go to the code here a little bit. We have a save DB function that's going to save it back to our server. We have a load DB function that's going to load it back up from the server. And the main one right here is going to just create a database, insert some data into there. It's going to select some data just to show that we actually put some data in there. If you see this iter dump, it's actually pulling out the transactions. So you're not actually saving the database, you're saving the commands to make that database. So you'll see like create table, scans, insert, XYZ, things like that. And that's what we're actually saving. And again, if you do it in memory, and again, this is a context manager. So as soon as you leave this context manager, it goes away. So just going to show you that too, that you have to be kind of careful about that because we're outside of the first one, but let's say we make a new connection to the memory. Obviously, it just disappeared. It got eaten up by garbage collection because we said we were done with it. And if we try to look for that again, it's going to error out, and that's right here, print. This will be hit because we are not going to have a table, just trying to show that. And then the load BB is going to pick back up from our server what we saved there. Kind of another cool thing I'll hit on here before we demo it is something called the IO import. So right here you can see we're going to make a temp file. Again, this is making a file in memory, so we're not touching disk. And we're going to write our SQL transactions to that file and then send that over so that we don't have to create a file on disk to do it. So what this should do is create a table, write some data to it, save it to our server, and then our server is going to send back that DB file to us so we can read it again. And so that went pretty fast, but the select right here is what you're seeing in this first one. That's the data in our database. This will be hit was when we tried to access that memory again. We got out of that context, so it destroyed the database. And so this will be hit, no such table name scan data, which we expected. And then when we loaded back up the database, you can see again, we're going to try to select that data again, and we got it this time because it set it back over. And you can see on our server side here, we have a scans file that's actually just the transaction data. Okay, so that's pretty much it for the examples, but I wanted to put it all together just to show you like how useful could this be to me. Those are pretty short examples of doing something. But let's say you wanted some kind of control and command. So you just want to be able to run commands, give it some data, and do some stuff. Show you the scan file. So this is going to be a whole script we're going to send over. It has schedule in it, something that our computer shouldn't know anything about because it's not installed. But we're going to read it from GitHub. And we're going to save a database every 5 seconds, I believe. That's what we're going to schedule to do it. Basically, we're going to pretend, whoops. We're going to pretend this is a scan, even though it's not. We're just going to put data in a database and throw it back. And so you could think about this like, what if you wanted to scan hosts around you and then keep updating some central database? You could have every client you have send back to your server all the data it's getting, and then re-ingest that in your own database that's central so that you know more data about it. And yeah, so all this is going to do is schedule every 5 seconds to do that scan. And the runner is pretty basic. It doesn't do a whole lot other than the first thing it does when it runs the command is it checks to see if it has any imports that need to be imported. Again, because a lot of these are going to be coming into memory and we're going to stick them there. And then the main is just something I'm making in my scripts I'm sending across so I know what to run. Okay, and this is just on a loop too. So when we run this, you can see it imported the scan, and then we also have one called run because you need something to actually hit the schedule to tell it to actually run the job that it's supposed to be doing. But you won't see scan ever show up again because I have it off the command list after the first time. So every 5 seconds we're running a scheduled scan basically in memory to a database, send that database back to us so that hopefully you can do something useful to it. And you'll see we're getting database files with timestamps on them from that scanning actually. And that's pretty much my talk. I just want to give a thanks to DakotaCon for inviting me out to give this talk. There's a bunch of links on here. There's a link to the repo of code that I was just showing. Again, HTTP import's pretty cool. That's the memory importer. If you don't want to write your own, schedule the scheduler Python program. And then these last few links are about basically how importing works in Python. If you want to read more about that, there's a bunch of links there. And with that, I guess, are there any questions?
The database scan files, that's on your server side, or is it writing those to the client side?
So I'm saving them to an in-memory file. If you saw, again, this string IO, and it's just transactions. Let's select this. So I'm making a temp file basically so I can dump that transaction data, and then I'm sending that file from memory to the server. So it's never touching disk in the client. Okay. If you have any questions and you see me around the con, don't be afraid to ask. Other than that, that's it.
What's that?
What's new?
Wow.